just to ensure uninterrupted flow. If you have any questions, do stack it up in the chat box, and in the end, we can ask the esteemed resource person. Apart from that, a feedback form will be sent both Cisco WebEx as well as on YouTube. So you can fill that up along with a quiz form that we will share tomorrow. So today we will be dealing with two subjects in two different sessions. The first session is about hypothesis theory, when to select what statistical techniques. The secret to all of this will be shared by our esteemed resource person, Dr. M. Kannan. So sit back and learn as much as you can. I will pave way for you, sir, to continue because our participants are very excited to hear from you. Thank you.
Okay. Very good morning to you all, ladies and gentlemen. I'm really happy. Hope you had a nice sleep yesterday and you are in a very positive mental health. I belong to mental health field, so I'm more worried about your mental health than the physical health. Of course, I do, because we strongly believe that there is no health without mental health. So that's a important message that I wanted to give first. Uh, Please don't ever think that we are going to discuss a very, very difficult matter today. As I told you yesterday, the most easiest task on earth is doing research in the field of social sciences. My approach is till night 8 o'clock. I'll never tell lies. So I'm telling you right now. So it is a joke. இதை விட்டுட்டு மறுபடியும் நீங்க சீரியஸா பார்த்துட்டே இருந்தீங்கன்னா I cannot, because the subject is very serious. And the before starting, I'll tell you, my friends, I'm not a statistician. Basically, I am a social work professional, where I taught statistics for laypersons. I have motivated them, and on their own, they have completed PhD. That's a really important thing. They think that I really help them. No, not at all. They have interest for themselves, and thereby they have learned a lot. I was an instrumental for that. That's all. So, also today, I am going to be an instrumental, and I would like to tell you the very, very simplest way of doing statistics for your PhD or postdoctoral fellowship or your ML or whatever it may be. Okay, any research paper or any research work that you are going to do, if you follow, probably it will be accepted by the academic community. Let me start without wasting my time. I have a problem in how to share. Yesterday, I did.
Yeah.
Is it clear, madam? Now.
Yeah, is it clear, sir?
But can you see my face also? Because yesterday somebody said that they did not see my face. I was really happy. Hello.
Yes,
Gone.
sir.
Hello.
Yes, sir. You're audible and visible, sir.
Yeah. Is it okay now?
Yeah, now you can share your PPT, sir. It's open.
It's open, right?
Yeah.
Welcome to the 3-day online quantitative and qualitative techniques for social science research, organized by the Tamil Nadu Dr. Ambedkar Law University. Today we are in session 2 by myself, and the topic given to me was hypothesis testing or hypothesis theory, and very important, when to select what statistical technique, the secret. This is me. If you have any doubts and clarification, you can very well message me, or you can contact the email. If I know the answer, I'll try to respond to you. Thank you. During session 1, what we have discussed, let us quickly recollect. We talked about natural science, that is positive science, social science, that is normative science, applied science, that is combination of both positive and normative. As I told you, natural science or positive science, they study the facts as they are. Whereas in social sciences, we study the behavior of human being. And in applied science, we take one concept of positive science, merge with the normative science, and we say applied science. Next one, we talked about different types of variables. I would like to spend little time in this. Qualitative variables. when you talk about the characteristics of an individual or group of individual, we say it is a qualitative variable. Example, religion, caste, color, personality, etc. are called example of qualitative variable. Am I audible? I'm sorry.
Yes, sir. Yes, sir.
Fine, fine, fine. Second one is quantitative variable. Whenever you are able to express a variable in terms of numbers, then it is called quantitative variable. You are able to represent in terms of numbers, then it becomes quantitative variable. Then independent variables are independent to each other, but they are called the contributing variable for the dependent variable. Supposing that I wanted to study the quality of life of a person is depend upon so many variables. So quality of life is called a dependent variable or otherwise known as study variable or otherwise known as outcome variable. That is the outcome of our study. Friends, the reasons for quality of life or the factors influencing the quality of life will be called as the independent variables or predictor variables or contributory variables. They are contributing for the dependent variable. They are predicting the dependent variable. Therefore, all these variables are to be understood properly. Otherwise, today we may not be in a position to understand or relish the importance of statistics. I'll give another clue to all the beginners of research. Whenever you wanted to formulate a title for a research work, see this formula or apply this formula. One independent variable plus one dependent variable plus the study area constitute a title. Okay, there should be one independent variable. That should be the first one. Second one, dependent variable and the study area, the place in which you wanted to conduct the study. If you connect, then you get a research problem. That's the shortest way of telling how to formulate a research problem. Okay. Now, whenever you have only one variable, study variable in a place, that is a very simple study. Like I want to study the psychological well-being of the corona affected persons. That's all. There is only one study variable called psychological variable. Okay. But if I want to increase the power of the research title, then I have one independent variable plus one dependent variable plus a study area, the place in which I want to study. Then it becomes a study or research work for MA level or MSc level or ML level. If you want to do your PhD, there shall be two or more number of independent variables. I'll repeat, let there be two or more independent variables plus one dependent variable plus one study area. It is your PhD work. It is a crude way of formulating a research problem. Meaning what? The study variable should be at the end of the work, research work, like psychological well-being and quality of life of persons dependent on alcohol. Okay, so
Excuse
the
me, sir.
yeah.
Uh, we couldn't see PPT, sir. It's not visible.
I could see that. That is a.
Kindly try sharing again, sir. Maybe it will work.
When I select the sharing, should I select the entire screen or window?
File option, sir. Next to the window.
First press the window, then file option. Okay.
No, sir.
Is it okay?
Yes, yes, sir.
Okay, sir. Okay.
Yeah.
But I'm not able to see my face. It's okay. No?
We are able to see it, sir.
The slide. Can you see the slide?
Yes, sir. We can see the slide as well as your
Okay.
screen.
Okay. Then fine. One minute. Let me adjust my screen so that. Okay. 1 minute. goes like this. Can you see the full screen of mine?
No, no,
Okay, no. Now?
no.
No.
Darwin,
Sir, you shared your total screen, sir. Go to the file option, sir. File sharing.
1 minute, sir. 1 minute, sir. I'm sorry. I'm clinically illiterate in this matter.
Okay.
Because we are all familiar with the Zoom and the Google Meet. So it is a new software. I don't know. But anyhow, share. First, share screen. Then
Not
Windows.
screen, sir. Your
Uh,
file option is there, sir. One file option next to the window.
oh, Chrome tab is there. No. Window.
Window next to file, sir. File. Not clicking window, sir.
I have to click Windows. Okay, fine. I've clicked Windows.
Darwin, தமிழ்லே சொல்லுங்க
Not
அவங்களுக்கு
window, sir.
புரியும்.
Window, sir. சார் ஃபைல்
இல்லம்மா,
ஃபைல்
இல்லம்மா.
இருக்குல்ல சார் ஃபைல் விண்டோக்கு அடுத்து ஒரு ஃபைல்னு ஒரு ஐகான் இருக்கு சார்.
இல்லையே விண்டோக்கு அடுத்தப்பல குரோம் டேப்னு தான் இருக்கு கண்ணா.
ஃபைல் ஆப்ஷன் ஒன்று இருக்கா சார்?
ஃபைல் ஆப்ஷன் அதனால தான் நான் கேட்டுட்டு இருக்கேன். என்டையர் ஸ்கிரீன் இருக்கு, விண்டோஸ் இருக்கு, குரோம்
Or
டேப்.
otherwise you send your PPT to our technical person, sir. He will connect you.
1 minute. I'll try my line. One second. There is no issue. Share. So I have to cancel this one. 1 second, please. Just slowly. One second. Sorry. One minute, I'll just go out and come back. That will be better.
So make unmute and we can speak through mobile, sir.
1 minute, madam. I'll just.
இப்போ அவர்கிட்ட பேசுங்க.
Dear participants, we will just resume in like less than a minute. Meanwhile, you can just utilize the time to recollect what was discussed in yesterday's session. So will be joining us in less than a minute and then we can continue.
Okay. Now I have. I have a screen, a share screen. Darwin sir. Darwin sir.
Darwin?
Fine. Thank you very much.
Yes, yes, sir, yes, sir, yes, sir.
Thank you very much. Hello. Can you all hear
Yeah,
me?
yeah.
Yeah.
Yeah, yeah,
Yes, sir.
visible.
Next slide. Next slide. Okay. Next slide. Next. 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 Stop. No, previous. No. Previous. Previous, please. Previous, I said. Previous.
Go back. Go back. Previous one.
Stop.
Yes, yes. Stop.
This is where I have stopped. Well, welcome back after a short break. I think you're all ready for the session. Well, I was talking about different types of variables, and I have given an example of how to formulate a research problem by using independent, dependent, and the place in which we want to conduct a study. Okay, next slide, please. Well, we like to recollect the four levels of measurement. Friends, I'll tell you, if you don't understand the four levels of measurement, you cannot understand or apply the statistical technique for the hypothesis that you have formulated. Okay, Now, nominal, ordinal are called qualitative variable, interval, ratio are the quantitative variable. Nominal is a qualitative variable where there can be only categorization. Ordinal is a qualitative variable where there will be categories, but those categories arranged in an interval variable is a quantitative variable where it is explained in terms of numbers. However, the real zero is absent. Ratio variable is a quantitative variable numerically expressed, but the real zero is present. So these are all the things that you have to remember. Next slide, please. Now let us come to the topic for discussion today, a hypothesis theory. The definition for hypothesis is a tentative statement or generalization or assumption அதோட நிப்பாட்டிடக்கூடாது, which needs to be tested empirically or statistically. Many of the research scholars are defining or proclaiming the hypothesis, but they are not proving it empirically. That is not correct. Hypothesis is a singular, hypothesis is plural. THESES means plural, THESIS is a singular. Okay, it is a tentative statement or generalization or assumption which needs to be tested empirically or statistically. Next slide, please. I have given the common four important conditions for a good hypothesis. If you satisfy the four conditions that I have mentioned here, probably you can say, "Hey, good, great." You can pat on your back that you have formulated the hypothesis. The first condition is there should be minimum of two variables. Hypothesis is a sentence or generalization or a statement which needs to have minimum of two variables. Number two, the variables are to be defined and measured. It should be properly defined, and you should also tell us how you are going to measure the variable. Number three, there should be some linkages between the variables already. When you are taking two variables, you should not connect to two different variables. You connect two variables and see to that there are some linkages already. Okay, how can you say that there are some linkages already? Nothing but your review of literature, the previous studies. Okay, the previous studies would show that there is some linkages between the variables. Supposing that there is no previous study, remember, you have been working in the field for a longer time. Based on your personal experiences, you can formulate your own hypothesis. So that is called, there should be some linkages between the variables. Last one is that linkages should be tested or verified empirically. Without testing it, then it cannot be called as hypothesis. Or let me repeat. One second, one second. One second. Please. Previous slide, please. So minimum two variables, that it should be defined and measured properly. There should be some linkages between the variables. That linkages should be tested empirically. Wait a minute. I'll give an example. For example, I say higher the loneliness, higher will be the smartphone addiction. When a student is very much lonely, has the feeling of loneliness, that fellow is likely to become social media addiction. Higher the loneliness, higher the social media addiction. There are two variables. First condition is satisfied. Second, I'm going to define how the loneliness is defined and how it can be measured. Then social media addiction, how it is defined and measured. So I have on the standardized scale, or I should have defined it properly or measured properly. There should be some linkages. There are literature available. Third condition is satisfied. That linkages should be tested empirically or statistically. Well, here is the role of statistics. When I say loneliness and it is being measured using a scale, it becomes interval level. When I say social media addiction, it is defined and it measured and it becomes interval variable. So I have two interval variables which are quantitative in nature. So the rule of a thumb is whenever you have two quantitative variables and you want to find out the association, blindly you can seek the help of Carl Pearson's coefficient of correlation technique. Friends, this is a business secret. I'm letting the cat out of the bag. So I talk to you very theoretically that I have two variables and two variables are measured and it is in interval level, quantitative nature. I have some theory behind it, and I want to test. Therefore, I go for Carl Pearson's coefficient of correlation. Simple. So this is an example of a hypothesis. Later, we'll see various types of techniques. Next slide, please. I hope I'm making myself clear. நான் உங்களுக்கு புரிகிற மாதிரியே பேசுகிறேன் என்று நினைக்கின்றேன். Right. Let us talk about quickly the different types of hypothesis. Why? If you know the types of hypothesis, then you'll also select the appropriate statistical technique. Okay. Now, simple hypothesis. I'll tell you quickly. Let me discuss. Simple hypothesis means whenever you have two variables, then it becomes simple hypothesis. Again, I'm telling you, these types or classification, this is purely based on our own convention. There is no hard and fast rule. Okay, simple hypothesis means only two variables. Fine, but then what does it mean? Complex hypothesis. Whenever you have more than two variables, it becomes a complex hypothesis. What is relational hypothesis? Whenever I talk about, please understand, whenever I talk about relationship or association between the variables, underline between the variables, it becomes relational hypothesis. Okay. Now, coming to the other point, a relational hypothesis may be a simple or a complex. So I go further. In relation, I can have a simple relational hypothesis, complex relational hypothesis. Clear? Now, next one, difference. Please take down. Whenever I want to find out the differences between two or more groups, underline groups. Whenever I wanted to see the differences between two or more groups, then it becomes difference hypothesis. For example, male and female, I want to see the differences. I'm not going to talk about the association between male and female. Rather, I would prefer to find out the differences between male and female, educated and illiterate. So whenever I want to see the differences between two or more groups, then it becomes difference hypothesis. Fine. Again, a difference hypothesis may be a simple difference hypothesis or a complex difference hypothesis. See how I'm generating hypothesis. If you understand these technicalities a little bit, then you can select the advanced statistical techniques without any difficulty at all. I swear I mean it. Now, what is research hypothesis? Yesterday, a friend of mine asked, what is research hypothesis? Friends, a hypothesis derived from research question is called research hypothesis. Generally, research hypothesis will be very vague in nature. It cannot be tested directly. For example, higher the psychological well-being, lesser will be the social media addiction. So this is the research hypothesis. What will be the research question? Is there any connection between psychological well-being and social media addiction? What the question mark? So that is a research question. Can you say that a person who has psychological well-being or more psychological well-being will never become a social media addict? That is a question. So from that, I'm trying to draw a hypothesis: higher the psychological well-being, lesser the social media addiction. Research hypothesis. But unfortunately, my friends, that statement that I have mentioned just now, called higher the psychological well-being, lesser the social media addiction, cannot be tested directly using statistical technique. Therefore, we go for statistical hypothesis, which means we have got two. One is called null hypothesis, another one is alternative hypothesis. What do you mean by null hypothesis? Whenever I am trying to nullify the effect of two variables, it becomes a null hypothesis. In this example, my hypothesis is higher the psychological well-being, lesser the social media addiction. The null hypothesis would be there is no association between psychological well-being and social media addiction. I am nullifying the relationship. That's why I say there is no association between psychological well-being and social media addiction. That is called null hypothesis. Then what is alternative hypothesis? Then first alternative, there used to be only three alternative hypotheses. Number one, when I say there is no association as a null hypothesis, there is association is alternative hypothesis number one. Okay, there is association between psychological well-being and social media addiction. HA1, alternative hypothesis 1. HA2 is higher the psychological well-being, higher will be the social media addiction. Alternative hypothesis number 2. And the last one is higher the psychological well-being, lesser will be the social media addiction, which is nothing but my research hypothesis. Friends, I have to convert my research hypothesis into null hypothesis, which is known as H naught throughout the world. HO, it's called H naught throughout the world. I have to convert it to H naught because, please mark my words, make it as a box and say, write it in within the box. All the statistical tests are verifying the null hypothesis. Therefore, when you want to test your research hypothesis, you have to go to statistical hypothesis format, make that as a null hypothesis, then prove or disprove. I wouldn't say prove or disprove. I would say that accept or reject the null hypothesis. That is called testing hypothesis. So we require statistical hypothesis called null and alternative. Then what is non-directional hypothesis? When I don't give any weightages or direction, then it becomes non-directional. Example is there is association between well-being and social media addiction. I'm not giving any direction. That is called non-direction. That is association. Anybody can say, but what type of association? I'm going to take a lead. When one is increasing, other is going to decrease or increase. That means I'm going to take a stand. Then I will say higher the psychological well-being, lesser the social media addiction, or higher the social media addiction. I take a stand, and that is called directional hypothesis. Friends, the clue is whenever you are doing any experimental research design, it is always better to have directional hypothesis. Why? When you have a directional hypothesis in statistics, we'll go for one tail test, which is called the powerful test. Okay, when you have a non-directional hypothesis, you can go for two-tail test, which is ordinary test. So the types of hypothesis will tell you the sophisticated statistical technique that one has to select. Next slide, please. Hope I'm making myself clear. Okay, next slide, please. Now let us come to the business. What are the steps to be followed while you're trying to test the hypothesis? Basically, there are 5 steps. Number 1, set up hypothesis. Number 2, set up critical region. Number 3, select the appropriate statistical test. Number 4, do the calculations or computations. Number 5, results or decision making. Now, first step is called set up hypothesis. Already we have discussed various types of hypothesis. Okay, so that part is over. Number 2, set up the critical region. Friends, in statistics, we have to talk about a normal distribution curve, which is called a bell-shaped curve, where there will be a center line is there, and that center line is called your mean, median, mode, or your types of averages. Okay, the central line indicates the averages, mean, median, or mode. Mean stands for arithmetic mean. Okay, this is called a normal distribution curve. Now, when you say critical region in statistics, by and large, we say 95% of confidence and 5% error. What do you mean by 95% of confidence? Supposing I say that my hypothesis is true or accepted at 95% of confidence, okay? Now, what does it mean? When somebody wants to take the similar study, I'll repeat, when somebody wants to take a similar study, and if they have interviewed 100 persons, my results will coincide with at least 95% for 95%. Okay, that is why I make a statement. It is true for 95 level of confidence, 95 percentage of confidence. Percentage of confidence and percentage of error, they go hand in hand. When I say 95 percentage of confidence, it goes without saying the remaining 5 percentage is called percentage of error. In social sciences, the default is 95 percentage confidence and 5% error. In natural science, they go for 99.99 percentage of confidence. Okay, 99. That means when somebody is interviewing 1,000 persons, for 999 persons, the results should be true. There can be error for only 1% out of 1,000. That means 0.001 level. That's the meaning of it. 0.001 level means out of 1,000, there is only one person who just will be away from the results. That is why we say 0.001% level of confidence instead of 0.05. So these are all the techniques. So in social statistics or social science research, we take 95% of confidence and 5% error. The third step is select the appropriate test, which I'll tell you later. Now let us assume that we have selected one statistical technique. Now apply the formula and calculate the value, and that is called fourth step, do the calculation. Supposing that I have chosen chi-square test, which is called a statistical non-parametric test. I have chosen, let us assume that I have a formula chi-square equivalent to sigma O minus E whole squared by E. Don't worry about it. Everything will be done by computer. My friend, Professor Duraiswamy, will talk to you afterwards, and he'll show within fraction of microseconds, he'll show the chi-square results. So don't you worry about it. So chi-square is a test. So I have chosen. Then calculate using all the table, etc., etc. Then calculate value, and that is called fourth step. Do the calculation. End of the fourth step, you'll have one value, and call that value as calculated value. Calculated value. Then fifth step. The fifth step is for that particular chi-square test, based on degrees of freedom, there will be one standard value. Don't worry about all technicalities. You have got one value, and there will be another value called a standard value, which is nothing but table value. Now, our responsibility step is to compare the value that you have computed with the standard value. So whenever you have two values in mathematics, there could be three combinations. What are the three combinations? Your calculated value may be equivalent to table value. Number two, your calculated value may be less than table value. Your calculated value may be greater than the table value. Okay, so these are the probable ways of comparing two values. Based on that, you have to take a decision. Please take down in your notebook, when calculated value is equivalent to table value, accept null, accept H naught. That's a rule of thumb. You may be knowing it, but I'm recollecting it. CV, calculated value, is equivalent to table value. You say accept null. Calculated value less than the table value, accept null. Calculated value greater than the table value, reject the null. Remember, always I am referring to the null. Why? Because all the statistical techniques would really test the null hypothesis. Therefore, you have to say accept or reject null. Now, coming back to the first point, CV is equivalent to TV, accept null, which means reject the alternative. I'll repeat, accept the null meaning is equivalent to reject the alternative. Reject the null is same as accept the alternative. Right? So this is the rule of thumb. Next slide, please. Hope I'm making myself clear. Okay, next step. Now, before you are going to test the hypothesis, this is called a template. If you could formulate the template without any difficulty, you yourself can verify whether or not you have formulated the hypothesis as per the conditions which I have said. Now, first you take a research question or Q, formulate the research hypothesis or H, then you make that as a null hypothesis H naught. Don't say HO, say H naught. Then alternative hypothesis 1, what is that? HA1. Sorry, I have forgotten to add A. Okay, HA1. HA1 stands for there is association or there is a difference. Okay. Now, alternative hypothesis 2, HA2, that one is greater than the other. Then alternative hypothesis 3. If we can formulate this template, probably for each and every hypothesis, you can have it separately in a piece of paper, then you can go ahead. You need not present this same format in your thesis. It is not warranted. But then in education, in psychology, some of the research guides are insisting that you have to mention the research hypothesis, then you have to mention the null, then you have to mention the alternative. That is a format they are prescribing. Follow that. I'll tell you one more secret. Those who are listening to me right now, the rule number 1, the guide is always correct. Rule number 2, if the guide is wrong, see rule number 1. I'm not joking. Rule number 1, guide is always correct. Rule number 2, if guide is wrong, see rule number 1. That is how you have to do your PhD work. Please don't antagonize with your research guide. He is the boss till you complete and get your degree. These are the golden words that I'm sharing with you based on the personal experiences. Okay, don't ever argue with your guide, and don't show that you're so smart than your guide. That's all you're trying to fight the ego of the guides. Of course, in a law, there won't be such persons like that. But then I'm just giving you a word of caution. Next slide, please. Oh, next slide, please. Next slide, please. I hope I'm making myself clear. Am I not, ladies and gentlemen?
Clear, clear.
It's absolutely clear, sir.
Okay, thank you. Okay. I'll be really happy when I talk about statistics. I'll be very happy than with my family. You know, when I talk about statistics, I am really into. I'll have more into, and I'll be in a jubilant mood. Okay. First of all, you have to understand normal distribution curve. What do you mean by normal distribution curve? These are little technical involved. Don't you worry. If you don't understand, no problem. Okay. Next session, our friend Dr. Duraiswamy will help you to do, and I think he will say, if you know how to use mouse, you can use SPSS. That's all. That is a simple logic. Okay. Well, normal distribution is known as a standard normal curve, bell-shaped curve, unimodal curve. That's only one mode. Then it is symmetrical. Right and left are mirror image. All the central tendencies are the same. Mean, median, mode are same. It is a continuous curve, and it is asymptotic curve, meaning that it will never touch the x-axis. Okay, it will never touch the x-axis. Fine. Next slide, please. Darwin, sir. Next slide. Yeah. Please understand, my friends, before you go for any statistical analysis, the first and foremost thing that you have to do is data cleaning or testing for normalcy. Okay, data cleaning or testing for normalcy. Okay, what do you mean by data cleaning? Whenever you have a variable, like for instance, social media addiction, and if the scores ranges between 0 and 70, you may have some of the respondents who have got 3, 2, or 70, 68, 69. Very few of them. These people are called extreme valued people, and it is called outliers. Because of the outliers, your mean value, standard deviation value will be affected, and therefore you may not get the real results properly. So it is better to trim that extreme outliers, or you have to do some work called data transformation, which is slightly technical, which I don't want to disturb you right now. So whenever we are going to have a separate session, we'll do that. So remember that the outliers or the extreme values will give disturbances. Yesterday, our NAC advisor was also talking about missing value. So not only extreme values, even the missing values. Data the the missing value will also create problems. So all things should be removed, and we need to have a homogeneous data. Whenever you have a heterogeneous data, your statistical results may not be applicable. So let it be homogeneous data. So there are certain assumptions when you go for statistical technique. One such assumptions is called homogeneity of data. So how do we take homogeneity or normalcy? First, to check whether mean value is equivalent to, almost equivalent to median value, or almost equivalent to mode value. Then you can very well say that, oh, my data is normally distributed. Right. Second technique would be KS test. In SPSS, non-parametric, there is one option called Kolmogorov-Smirnov test, followed by Charpy test. Remember, the rule of thumb is this KS test and Shapiro test should not be significant. Please make a note of it. It should not be significant. If it is significant, then your data is not normal. If it is not significant, then the data is normal. Okay, next. Next. Uh, these are all the ways through which you can group the data. There are certain occasions where you have to group the data. This is not required right now. The first way of grouping the data is based on the median test, below median, above median. Then based on the quartile deviation method, based on the top and bottom 27% of data, wherein the psychology students would apply that. Then using mean and standard deviation value, and based on the theoretical value. So these are the ways through which you can group the data. Okay, next. Next slide, please. Now coming to the various tests. Okay, broadly we can have. Okay, broadly there could be two types of tests. One is parametric test, another one is non-parametric test. Friends, whenever this is a rule of thumb, whenever you have your data or the variables that you are going to study are normally distributed, then kindly go for parametric tests, which are called the powerful test. Okay, it's a powerful test. Non-parametric tests are distribution free test, and whenever you have your data not normal, then you can go for non-parametric test. Non-parametric tests are not bad, but then it will not give that much accurate results, like a parametric test. Okay, next slide, please. Hello, we have little time. This is called one-tail test. I told you already. Whenever you have directional hypothesis, go for one-tail test. It's a clue. Whenever you have a non-directional hypothesis, you can go for two-tail test. Next slide, please. Now only I'm going to talk about the step number 3. You remember there are 5 steps to be followed while you are testing the hypothesis. Now I'm going to discuss the step number 3, that is called selection of appropriate statistical technique. Friends, இதுவரையும் ஒண்ணுமே புரியலாம் கூட பரவாயில்லை, பட் இப்ப மாத்திரம் புரிஞ்சுக்கங்க. What I want to tell you is that so far you have not understood anything, doesn't matter. Now concentrate, focus on what I'm trying to tell you, make some notes, then apply or select the statistical technique. This is called business secret. I know everything is available in the statistics book, but then I'm just giving in a very, very ready reckoner manner. Hope I'm making myself clear. Now, first technique is called Pearson's coefficient of correlation test. Friends, when you go for it, point number 1, please take down. When you go for Pearson coefficient test, number 1, your 2 variables should be quantitative in nature. That means either interval or ratio. Okay, your 2 variables that you have chosen should be quantitative in nature, and your objective should be to find out the association between 2 variables. Example, higher the psychological well-being, higher the quality of life. So that is an example. So I have 2 quantitative variables, okay, and I want to find out association. Blindly, you just go for Pearson coefficient of correlation. Well, the correlation value ranges between -1 and +1. If the value is negative, that means if the 2 variables are negatively correlated. What does that mean? Negatively correlation means when one variable is increasing, another variable will be decreasing. For example, psychological well-being is increasing, media addiction is decreasing. Negative correlation. If the R value, we call it a small r, if the R value, correlation value is positive, that means when one variable is increasing, other variable will also increase. That is called variables moving in the same direction. It is called positive correlation. So when you have a positive value, it is positive correlation. When you have a negative value, it becomes a negative correlation. So you may have a question, what happens if I get zero? Zero means it is no correlation. But my friends, you will never get the theoretical correlation is -1 +1 or 0 in reality. However, when you are correlating the same variables x and x, you get a +1 correlation. Okay, that's about Pearson's coefficient of correlation. Second one, when I have more than two quantitative variables, I'll repeat, when I have more than two quantitative variables, then I have to prepare a correlation matrix. That is test number 2. I have psychological well-being, quality of life, social media addiction. I have three variables. When I have three variables like A, B, C, I can have three types of correlation. What are they? A versus B, A versus C, B versus C. So I will have a correlation. The value will be -1 to +1. Second technique is correlation matrix. Third one is called simple linear regression. Here the condition is you need to have a quantitative variables. Okay, you need to have a quantitative variables out of which one variable is independent variable, one variable should be the dependent variable. In other words, one variable is the causative variable, another one is should be the outcome variable. Example, I want to study the media addiction. It's a dependent variable. What is the independent variable? Psychological well-being is independent variable. So I wanted to connect. This is called simple linear regression. This technique was propounded by Sir Francis Galton. You know Francis Galton? Sir Francis Galton and Sir Charles Darwin were cousins. Sir Charles Darwin is a biology man. Both of them are joined together and they have established the first psychological laboratory in the field. So they were just collecting the information from the public. Now what they have done, they have called 1,000 fathers. I mean the biological fathers who have produced sons or daughters. Okay. Now 1,000 persons they have interviewed. They have measured the height of the father. Also they have measured the height of the sons. Then they were doing some analysis. Who did analysis? Sir Francis Galton had done some analysis. And he found out a beautiful theory, and he stated in his book, tall fathers tend to produce tall sons. Okay, tall fathers tend to produce tall sons, and short fathers tend to produce short sons. Finally, if you tell me the height of the father, I can predict the height of the son, vice versa. That's what they said. So they have found out an equation called y equal to a plus bx, where y equal to dependent variable, a and b are constant, x is an independent variable. That is called simple linear regression. I want to find out to what extent my independent variable is contributing towards dependent variable equation. That's called simple linear equation. Again, a quantitative technique. Third, when I have a simple linear regression, I have not mentioned here additional information. I'm just telling you, my friends. When I have more than two or more independent variables, and I have only one dependent variable, then I can go for multiple linear regression technique. I'll repeat, when I have only one independent variable, one dependent variable, simple linear regression. Okay, fine, that's good. When I have more than two or more independent variables towards a dependent variable, And if I want to find out how these independent variables are influencing the dependent variable, I have to go for multiple linear regression. Okay, friends, in SPSS, there are a lot of techniques available, and in multiple regression, there is one technique called, or one method called, stepwise multiple linear regression technique. That is the boon for researchers. I'll give an example. Supposing that I have 10 independent variables towards a dependent variable. Make 10 independent variables and one dependent variable. You wanted to find out of these 10 independent variables, which variables are influencing the dependent variable. You can find out by using the technique. Supposing that out of 10, only 5 variables are influencing. That means the remaining 5 are not at all important. You can throw it away. You can take a proper decision. So that is the first advantages. Second advantage would be, out of these 5 selected independent variables, what is their individual contribution towards the dependent variable? Now I say is variable number one. Variable number one, to what extent they are influencing, which is known as R square value or percentage of variance. To what extent that particular independent variable alone could contribute. That is called stepwise regression. So the stepwise regression will really will be considered as a boon for your social science researcher. Finally, all the 5 selected variables put together, how, to what extent they are contributing together. So 3 points could be studied with the help of multiple linear regression, which I have not mentioned. Okay. Now, second, so far I was talking about association types of hypothesis or relational. Next, we will move on to the difference types of hypothesis. Independent sample t-test. Independent sample t-test is, it is a kind of a difference hypothesis. I remember, I would like to recapitulate what I have said earlier. An association or relational hypothesis is talking about the relationship between 2 or more variables, underlying variables. A difference hypothesis is describing the differences between 2 or more groups. In the independent sample t-test is an example for a difference hypothesis, wherein I want to say that male and female, with regard to the domestic violence, let us say females are facing more domestic violence than males. Because males also can have a domestic violence. No, there may be some wives who will be torturing the men. Okay, let us say we can hypothesize that females are facing more domestic violence than males. That means it is an example for a difference hypothesis. I'm not talking about association here. I want to see the difference between male groups and female groups with regard to domestic violence. Or I would say that females are having more social media addiction than males. Just I'm giving an example. Don't think otherwise. Why this fellow is talking about always about females? No, no. Just give an example. Or let us put it this way: males are more social media addicted than females. It is an example for the difference. So, in that occasion, whenever you have two groups, you have to go for independent sample t-test. What are the conditions? Number one, please take down. There should be minimum of 2 groups, only 2 groups, and your objective is to find out the mean differences, to test the mean differences between the 2 groups. You have to go for independent sample t-test. Okay, the t-test will give you the result. The t-test value ranges between minus infinity to plus infinity. Don't worry about the sign. If it is significant, how do you say it is significant? By and large, if the size of the sample is more than 30, the standard value is 1.96. You can very blindly say that. I'll tell you, the easiest task is learning about statistics. Okay, if you say that the t value is more than 1.96 and the size of the sample is more than 30, say that it is significant. Male and female are different. Then you will ask a question, sir, who is having more internet addiction, sir? Then go to the mean value. go to the mean value. If you find that mean value is more for the male community, say that males have got more internet addiction than the females. That's all, your honor. So that is about independent sample t-test. What do you mean by paired sample t-test? Take down the condition. Whenever you are dealing with the same samples at different points of time. For example, I conduct the test for 30 samples at the pre-test level before intervention. Same persons for after the intervention. I have the same data. I'm sorry, I have data for the same samples. It is called paired sample t-test. Okay, the same population at different points of time, and you want to find out the mean differences. You have to go for paired sample t-test. Now, next one is t-test for significance of R value. Fine. I talked about Carl Pearson's R. You get a value of R is equal to 0.75. Let us say 0.75 is the R value. Friends, if the statistician would argue with you that, 0.75 may be purely by chance, they will not accept the R value just like that. They'll say, tell us whether or not the R value is significant. That means whether we can rely upon the R value. Friends, to test whether or not the the R value is significant, you have to run a T value for an R value. Okay? So don't worry, I just talk too much, but it could be done within fraction of microseconds in SPSS. When you ask for a correlation test, it will give you a star mark on above the R value, correlation value. The star indicates whether or not whether or not it is significant. If the star is single star, it is significant at 95. If it is double star, it is significant at 99%. So t-test for testing the significance of R is another statistical technique. Sir, I don't know anything, sir. I have only correlation value, sir. Don't you worry about it. When you have a correlation value as 0.4, okay, 0.4 as a correlation value, you say that there exists a correlation. And if it is significant, then say it is a real correlation. Then further you can say that you square that 0.4, make it as square of 0.4. It is called 0.16. And that 0.16 is that much percentage of prediction is possible with independent or dependent variable. Correlation between two variables is 0.4, then R square is called 0.16, which is called coefficient of determination. To what extent that particular variable is contributing. That is called coefficient of determination. Which I have not mentioned in the slide. Okay. Now, one way or another. In the t-test, in the independent sample t-test, I dealt with only two groups. Okay, I dealt with only two groups. But in reality, we may not be having only two groups always. We may be having three groups. For example, Hindus, Muslims, and Christians. I have three groups. And if I know only against that their social media addiction, let us say, I have a sample of 40, 40, 40 or unequal samples. Don't worry about it. I have three groups, and I have their media addiction, the score on media addiction. My question will be whether or not there's a difference between religion and the media addiction. So to answer to that, and if I know only t-test மாத்திரம் எனக்கு தெரிஞ்சிச்சுன்னு வச்சுக்கோங்களேன், நான் என்ன பண்ணுவேன், I'll do 3 times t-test. Like Hindus versus Muslim ஒரு t-test போடுவேன், Hindus versus Christian ஒரு t-test போடுவேன், Muslim versus Christian ஒரு t-test போடுவேன். It is right, but then you are committing more error in statistics. What does it mean? This is technicality, but then please understand. When I do Hindus versus Muslim, I admit 5% error. When I do Hindus versus Christian, again I admit 5% error. Muslim versus Christian, 5% error. So when I do 3 times, my percentage of error is zoomed to 15%. But in statistics, we allow only 5% error, no. So I'm crossing my percentage of error. Therefore, it should not be done. Like how 3 times t-test should not be done. And therefore, there is one technique which was propounded by Sir Ronald A. Fisher, Sir Ronald A. Fisher or R.E.A. Fisher, and he has found out ANOVA, analysis of variance. Okay, he has suggested this technique, and that is why it is called Fisher's ratio test or F ratio test or one-way ANOVA. So they are all same. One-way ANOVA or Fisher's test or F ratio test are one and the same. Okay. Am I going fast? I'm sorry. There is no time. I have to cover the portions. I think I'm making myself clear.
It's clear, sir. It's clear.
Okay, thank you. So when I have 3 groups, that is more than 2 groups, against one quantitative variable, and I want to find out the mean differences, then I have to blindly select one-way ANOVA or F test or F ratio or Fisher's test. Now, the F ratio test will tell that there is a difference between 3 groups. And that anybody can say, no, Hindus, Muslim, Christians, they are different with regard to media addiction. That anybody can say. Now, my next question would be, okay, when you say that there is a difference between the 3 groups, the next question should be, which of the pairs are significant? Which of the pairs? Is it between Hindus and Muslims? Is it between Muslims and Christians? What? I'll have another question. To answer to the question, Fisher has also found out a technique called post hoc test. That's called multiple range test. Post hoc test or multiple range test. Whenever you have your ANOVA results is significant, then you should proceed to post hoc test. If not, you stop it. So post hoc test will compare the means of the 3 different groups, and there are around 18 types of post hoc test. You can select the common Duncan test or Skeffey test. These are all the most popular distribution free or assumptions free kind of a post hoc test. You need not know that much of statistics. Okay, and I tell you, my friends, I'm sorry, I'm not degrading my professional colleagues. Whenever you want to do research in the field of social sciences, better you consult a statistician to certain extent, not more often. Quite often, don't go to him, because they'll all ask a lot of statistical theories, these, that, then you may not complete your research work. Okay, but I would suggest better you understand the basic concepts and you yourself can apply statistical technique. SPSS will be there. It's very user friendly, and you can do like SPSS. There are other softwares, R software, so many, SAS and all there. You can apply and get the results done. Now, so one-way ANOVA is over. So one-way ANOVA, more than 3 groups. I'm sorry, more than 2 groups, one quantitative variable, and if it is significant, you have to go for post hoc test. Now, what happens? I have 2 what you call qualitative groups. I'll give an example. One side I have a Hindu, Muslim, Christian, and media addiction. I also have a male, female, Hindu, Muslim, Christians, and media addiction. So male, female is a nominal group. Hindu, Muslim, Christian is a nominal group. I have 2 nominal different groups against one quantitative group, media addiction, which is in score. In that occasion, you please go for two-way ANOVA. It is called, you have a 2 categorical groups against one quantitative variable, and you want to find out the mean differences. Friends, in statistics, there is one great thing is there. A variable alone, when you take only one variable with another variable, they may behave differently. But when you take more than 2 variables, because of the presence of more variables, the variables will behave in different manner. What is it? I'll just give an example. When I have only one independent variable, one dependent variable, I can very well go for simple linear regression. But when I have more than two or more independent variables, the behavior of these independent variables will really influence differently with the different variable. You may get a different answers. Okay. So also, when you talk about one-way ANOVA, you may get significant difference. But when you go for two-way ANOVA, because of the introduction of another variable, you may not get the same results what you got for an ANOVA, one-way ANOVA. So you have to go for the appropriate test. Is it necessary to go for two-way? Fine. Yes, it is important. Go for it. Is it necessary? Not necessary. Yeah, it's okay. Go for one-way ANOVA. So the decision is yours. So these are all the different quantitative. Please, previous slide, please. Don't be in a hurry, sir. I have another 10 minutes to go. Yeah, these are all the quantitative techniques. These are the quantitative techniques wherein you have both the interval ratio variable and sometimes you have a nominal ordinal variable. So test number 1, 2, 3 are called relational, wherein you have only quantitative variables. Then test number independent sample t test, the paired sample t test for significance of R, one way, two way ANOVA. You'll have both the qualitative and quantitative variables. Okay. Next slide, please. Now, so far I talked about parametric test, which means you have a parameters. What do you mean by parametric test? Whenever you have a quantitative variable, you will be in a position to calculate the mean and standard deviation. Whenever you are able to calculate mean and standard deviation, when you are going to apply in a test, then those tests are called parametric tests. I have frequencies. I cannot take. Can I take the average value for Hindu, Muslims, and Christians? I cannot take the average value. But I can take the average value of media addiction of Hindu, Muslims, and Christians. That is different. This is different. I cannot take the average value of gender. Male 25%, female 25%, 25 plus 25, 50 divided by 2. What does it mean? It is nothing. It is useless, meaningless. I cannot take the mean value. Whenever I am not able to take the mean value, those are called qualitative variables, and therefore, in that occasion, you have to go for non-parametric test. This is all a ruled way of telling. If you see all these books, you will not find. Okay, I'm just giving based on my experience. Whenever you are not able to calculate mean value, don't you worry about it. You have a frequency distribution. Okay, then you go for non-parametric test. The best non-parametric test is chi-square test, which I mentioned the last. Chi-square test. Chi-square test was developed by Sir Carl Pearson. Sir Carl Pearson in the year 1900. Now, what do you mean by chi-square? I have male, female against media addiction, low, moderate, high. So I can have a cross tabulation. I have male, female, let us say 100 males, 100 females. Then the two variables, another variable is called the media addiction, level of media addiction, low, moderate, high. I cross tabulated and have a frequency. It is called 2 by 3 matrix. Male, female, low, moderate, high. I have a table. I cannot calculate the mean value. Therefore, what I have to do? I have to find out the chi-square value, which is called non-parametric test. It is the test which talks about the differences between observed frequency and expected frequency. Okay, it talks about observed frequency and expected frequency. Now, when you do the calculation of chi-square, you get a value and you have to compare with another value. So chi-square test is the non-parametric test, and it was proposed by Sir Carl Pearson. That is why I always used to say in my class that whenever you wanted to test your hypothesis, please believe Carl Pearson. Whenever you have a quantitative variables and you want to find out the association, Carl Pearson will come and help you. I have only qualitative variables, sir. I have only qualitative variables, sir. I want to find out the association, significance, etc. Chi-square. Again, Carl Pearson will come and help you. Now, the Edward Spearman's rank correlation test is non-parametric test, which is similar to Carl Pearson's coefficient of R. I'll repeat. Edward Spearman's rank correlation test is a non-parametric test, a qualitative test, rank order test, which is similar to Carl Pearson's R. Then you said the paired t-test, same population at different points of time. We have to go for paired t-test. When you have the data not normal, you have to go for Wilcoxon sign rank test, which is similar to paired t-test. Wilcoxon sign rank test is a non-parametric test. Right. I said about independent sample t-test, male, female, media addiction. It is quantitative in nature. If it is not quantitative, then I have to go for Mann-Whitney U test. Mann-Whitney U test is almost similar to independent sample t-test. Mann-Whitney is a non-parametric. Independent sample t-test is a parametric test. I have one way on a wall. I mentioned a Hindu, Muslim, Christians, then against a quantitative variable. If I have a quantitative variable, then I have to go for F ratio or one way ANOVA. If I am not, if my data are not normally distributed, go for Ruskell-Wallis test. Don't say Kruskal. K is silent. It is Ruskell-Wallis test. Previous slides are Ruskell-Wallis test. Ruskell-Wallis test. But whatever, say, I tell another test. When you have ordinal and ordinal variable, okay, low, moderate, high, the best technique would be gamma test. Then pi test, kappa test. So many tests are available in SPSS. But whatever you do, all non-parametric tests, the final confirmation technique is called chi-square technique. I'll repeat, even you do contingency t-test or kappa test or gamma test, the confirmatory test is chi-square, and that is why I kept chi-square at the end of it. So these are all the parametric, non-parametric tests, and I also given in the slide the equivalence of parametric test. Okay, next slide, please. Now, so far I have next slide, please. So far I have mentioned different types of tests. The end note is there are possibilities by the researcher to commit type 1 and type 2 errors. Friends, I told you, no, I have been, or we have to test only the null hypothesis. If the null hypothesis is true and you are accepting the null, that is, there is no association is true, and you are also accepting it, it is a correct decision that you have made. On the other hand, the null hypothesis is true, there is no association, but you reject it, then it is called type 1 error or alpha error. On the other hand, the null hypothesis is false. There is no association is not. That is, there is association. But you are accepting the null. That means you are doing type 2 error. When the null hypothesis is false and you are rejecting the null, then it is called correct decision. So these are called type 1 and type 2 error. Whenever you are selecting so many statistical techniques, like I started with the Pearson, then correlation matrix, simple linear, multiple linear, then coefficient of determination, then independent sample t-test, then paired sample t-test for correlation, one-way ANOVA, two-way ANOVA, then 4 or 5 non-parametric tests. All these tests are available. Now, in addition to that, my dear friends, there are advanced techniques like discriminant analysis, path analysis, factor analysis, okay, then SEM and AMOS. I'll tell you about factor analysis within a minute because I got another 5 minutes to go. Whenever you have a lot of variables, okay, and you wanted to group them scientifically, systematically, and you wanted to find out the meaningful factors, you go for factor analysis. I'll repeat, whenever you have large number of variables, let's say I have 25 variables, I cannot talk about all the 25 variables individually. So what I will do, I will run a factor analysis, which will help me. Variable number 1, 7, 18, 22 can combine together and they can form a factor 1. So I'm trying to reduce the number of variables into meaningful factors. That's called factor analysis. If I ask me to talk about factor analysis, I'll talk about for 2 hours because it has got a rotation, principal component analysis, this, etc. But understand the concept. When you have more number of variables and you wanted to group them into meaningful factor, go for factor analysis. Now, this is one. When I have more number of samples, I wanted to group them based on their similarities. See, I'm also wearing white shirt, somebody is also wearing white shirt. That is a similarity. I wanted to group the individuals. In that occasion, don't go for factor analysis, go for cluster analysis. Go for cluster analysis. Well, I have a variable map. Yesterday, I have shown variable map. I want to see the relationship between independent, intervening, and dependent path analysis. Which is the best path? You go for path analysis. Then you have done some experiments. You have done experiments, pre-test, post-test, in between review test 1, review test 2, etc. Don't go for ANOVA, you go for repeated measures of ANOVA. So there are so many advanced statistical techniques. And I want to standardize a scale, go for structural equation modeling or analysis of moment of structure. Okay, that is called confirmatory factor analysis. So these are all so many techniques. And I think my friend Professor Duraiswamy will make you to understand the simplest way of doing chi-square, t-test, correlation test, ANOVA test, etc. So these are all the different types of tests. And we have to follow the cafeteria approach. What do you mean by cafeteria approach? If you have your objectives, based on the objectives, you have to select the appropriate statistical techniques. Okay, and if you have a strong faith in quantitative, you go for quantitative. Sir, I'm not that much good in mathematics, go for qualitative. But my dear friends, the current trend is mixing both qualitative and quantitative. First you conduct a quantitative study, then take the findings, go to the community, have some focused group discussion or key informant interview, find out the reliability of the findings. That is called mixed methodology. Okay, so these are all the techniques available. And next slide, please. Hello, next slide. Yeah, these are all the techniques. And within the shortest span of time, I think I have 5 more minutes left over. I think if you have any specific questions, I'll take it. Otherwise, I request my beloved friend, Dr. Duraiswamy, to take over. Okay. It's pleasure talking to the people from heterogeneous group. And I must thank Dr. Ambedkar Law University for having provided this wonderful opportunity, especially Dr. Bhagavati and Dr. Sona, the registrar, then the NAC advisor, vice chancellor of Dr. Ambedkar Law University, and other professional colleagues of mine. Special thanks to my brother Srinivasa Raghavan yesterday, who gave some note about research and statistics. Okay, take care. One end note is statistics is the most easiest thing if you understand it properly. And please don't be panicked when you know nothing about it. There are people who are ready to help you. And as far as possible, you understand by yourself and do your work. If not you, then who? And I think you are capable of doing a wonderful statistical analysis with this limited explanations that I've given. With that, let me call it a day. Thank you very much. Over to the organizers. Hope I have made myself clear.
Yes.
Absolutely, sir. It was an honor. I would request the participants to put down the questions in the chat box if there are any. Due to paucity of time, we will just pick up 1 or 2 questions and we will share details of sir with you via email, and then you can get in touch with him if you have any more questions. So the chat box is flooding with thank you and beautiful presentation and friendly and comprehensive presentation. And there's so many, it was clear messages, sir.
Any, Sonu? Any questions?
No,
Any
ma'am.
questions?
Not really. We can
Yes.
continue.
So when I was listening your presentation, I remember one quote from which has been stated by Dr. Abdul Kalam sir. That is, teaching is a very noble profession that shapes the character, caliber, and future of an individual. If the people remember me as a good teacher, that will be the biggest honor for me. So it applies to you also. It was an excellent presentation. We will remember you as a good teacher and a good presentation. And it was very useful for us. So we will remember you till our lifetime. Thank you, sir.
One more additional. By accident, I became a faculty member of a school of social work. I was aspiring to become a naval officer, but I have landed in teaching community. So I have modified based on trial and error method, and now I am able to contribute something. Thank you very much for the nice
Thank you.
appreciation words.
Thank you, sir.
Thank
sir.
you,
Thank you, sir.
Sona. Thank you, Bhavadita.
Yes, sir. Yes, sir.
I'll be permitted to listen to my friend Dr. Duraiswamy's lecture.
Yeah, yes, sir. Of course. Of course.
Thank you. Thank you very much. Thank you.
Thank you so much, sir. So moving a little forward and getting into the second part of our session today, we have with us Dr. Duraiswamy, Professor and Associate Dean, College of Science and Humanities. Sir has been teaching economics and econometrics for the last 30 years. He retired as the HOD of Economics and the Dean of Humanities in the MCC Madras Christian College, Chennai. He's been adjudged as the best teacher of economics in Tamil Nadu for 2020 by the Elizabeth Adeskia Trust. He also received the Senior Economist Award from the Association of Economists of Tamil Nadu in the 40th Annual Conference. Sir, holding a PhD in economics from Madurai Kamaraj University, was also nominated as an executive committee member of the Indian Econometric Society for the years 2016, 1920, and 20 to 21. The Bar Council of India also nominated him to be a member of an inspection committee to approve courses of humanities offered by all law colleges in India. I think we would not have any better person to be with us today to conduct the second session, where Sir has also conducted 50 workshops on data analysis using statistical packages like SPSS, which we will be dealing with today, and eViews, through which at least 1,500 research scholars have been benefiting in analyzing and making their research better. It is an absolute honor to have you in our midst, sir. Without more delay, I would like to call upon Dr. Duraiswamy to take over and say a few words to begin, sir. I believe Sir is facing some network issues. Yes, sir.
No, there won't be an issue. Now it's
Yes,
clear?
sir. Now it's clear, sir.
It's
Yeah.
clear. It's clear.
Yes.
Yeah. Hello, sir. Kannan, sir.
Welcome.
Yeah, welcome. Hello. Nice.
Morning, sir.
Yeah, good morning. Good morning. Good morning. All of you. Okay. Shall we start?
Already we have given an intro about you, sir.
Oh, thank you, ma'am. Thank you, ma'am. Okay.
I want to say that.
So there is no need for me to hear that. It's good that. Okay, fine. So now I have to share Darwin.
Yes, sir. Yes, sir. You can share, sir.
Okay, fine. Screens. Darwin, I think you have to help me. Which one I have to click, Darwin? Windows, files.
Window, sir.
Window. Okay. Then that screen one. Am
Yes,
I right?
sir.
Okay.
Yes, sir. Yes, sir. Yes.
Then share. Okay. Then I'll get some join meeting. Adwa? No.
No, not, sir. Go to your SPSS tool, sir. SPSS
Okay.
tool,
Which
sir.
means my okay. Right. my desktop, huh? Okay.
Yes.
Where do I get that? No. First, I'll open it and then I'll get back. No? That's
Yes,
okay.
yes.
Okay,
Yeah.
that's better. Okay.
That's better.
Yeah, that's better. Even any number of workshops, I think we face this problem. Okay, okay. So I open it. Yeah, good, good. I'll also open some of the files. Okay. Yeah, good, good, good.
Other files you can close.
Other files, I think I'm closing it.
Yeah.
Now, get it. Expand panel video. Are you able to see that SPSS screen?
No,
No.
only Excel.
That is what other
Yeah, yeah.
Excel.
Yes, yeah.
This one? Some general survey?
Yes, sir.
An Excel data kind of a thing?
Yes, sir. Yes, sir.
Okay. So it's visible, right?
Yeah, it's visible.
Okay, fine, good. So now we'll start, fine?
Yes, sir. Yeah.
Okay, listen, my dear participants, first of all, I thank the university, Ambedkar Law University, for having given me an opportunity once again for sharing my experience in data analysis. And hope you had a good session with Dr. Kannan, who is an experienced person in social science, and social work especially. Am I audible? Am I visible?
Yes, sir.
Okay,
Yes.
my screen is also seen, right? Okay,
Yes.
fine, good. So the assumption here is that you had a good experience and you had good knowledge about how to construct hypothesis or how to collect the data, how to frame the objectives, and how did you select the topic, and how did you design your sample collection. All those things are over. You have an idea. It can be related to any topic. It can be related to the law related thing, or the police, crime, and all related to your domain. So though I may not be able to give you exactly what you want with the example of related to your domain, but definitely I think I'll make you confident that you can apply these basics, statistical analysis in your data analysis. And definitely this may not be enough. You have to practice and again, and then you can even think about some more qualitative data analysis. The recently added highly technical tools can be easily applied, so that I think your result and your publication will be better than the usual observation and writing something based on observation. Okay, because nowadays, whichever subject it is, we have to authentically say something. We cannot say that it may be like that, it could be like this. Given the condition, this may be true. So those kind of not so authenticated results are not well appreciated. Okay. And again, we are also aware of that it is very difficult to give 100% exact result of what has happened and what is happening and what is going to happen. One good example is the number of COVID death in India. Number of COVID death in the various states of India. Can anyone find out the exact death due to COVID in various states in India? whichever be the agency, even the World Health Organization can send a team. Is it possible to get the exact figure of how many people died because of COVID-19 in various states, various districts in India? Definitely not possible. Every method will give you a little bit better figure. Okay, so you can say take that, sir, number of cremation happened, maybe one better data. Number of bodies had gone out of the hospital can be counted, that may be a good data. So whatever addition in your methodology may make your result better and better, but not 100% perfect one. So this rider we must always believe in. Any research, it is very difficult to touch that 100% perfect, but we are always aiming towards that 100% perfect. And for that, we need a better approach. The better approach can be divided into two categories. One is qualitative approach, the other one is quantitative approach. Qualitative approach of what? Approach of the information which we gathered. Okay, research is nothing but start with the question and convert that question into hypothesis, and the hypothesis have to be tested. To test that hypothesis, we badly need information. We badly need data. Okay, we have the data. What do we do next? How do I test this hypothesis? I get information. I have got, say, 10,000 values. I've got 10,000 values. So how do I compress this and get one value by which I can say this hypothesis is true or false? So research is a step-by-step process. Identifying a research topic is very important, and based on what it basically based on your interest and the need and the availability of data. Somebody may say that, I want to do corruption in legal system. Sorry to say that, but I'm just bringing that. Corruption in legal system, corruption in police system, corruption in government. I want to do something. But is it possible for me to collect the data related to that one? Okay, so I may again go for some kind of a proxy method, but how far that proxy method will be better result for me, we can't see. So my question here is that something which is very much needed, but it is not possible for us to get the things, but somehow we can go for it. So you choose a topic which is relevant to the society, which is needed to be given answer for it is a long pending question, or which is of your interest also. Okay, you may try to study why the person who had committed a crime do it again and again. What makes them to go for crime again and again? Or what is the success rate of a particular type of the lawyers, a particular region, or you can take those kind of things. So basically it is based on your interest, availability of information, and also the need of the society. Right now, so you have identified the topic, you have collected the information in the form of qualitative information as well as quantitative information. And as I told you, there are qualitative approach and quantitative approach, because some of the cases, quantitative, it is very difficult. Say, for example, perception about the legal system in India. I want to do an analysis of what people think about the legal system of the lower court or the high court or Supreme Court. What do people believe in? What people perceive or what is the perception about this one? I want to do it. Here, is it possible for me to do a quantitative analysis? It's very difficult. So I have to go for a qualitative one. Qualitative one of what? I will just try to gather information about what people think about it. People think about the accessibility. People think about the affordability. People think about the genuinity of the legal system. So all those things can be analyzed only from the perception by the respondent. So definitely the participants, those who are doing research, those who are already got doctorate, try to write some paper, please narrow down your, the question and what you are trying to achieve, what you are trying to answer for it. And then you choose the relevant approach, whether it can be qualitative or quantitative approach. But even if it is a qualitative approach, that qualitative approach can also be supplemented with the help of a numerical data analysis. And that is what we are going to try. I'll just try to inculcate confidence in you. You can go for that both qualitative and quantitative approach with this 1.5 hour today and 1.5 hour tomorrow also. Fine, okay. But it is very difficult to cover the entire thing because it's a kind of a ocean of technologies are there. Those who are interested, those who want to be better and better in that particular field, you have to search and you have to do repeated analysis, and then you will become a perfect researcher in that field. Okay, fine. There is no end for any research at any point of time. It is a continuous dynamic process of it. Fine, right. Now, quantitative approach is basically based on the quantitative information we collected and we apply some statistical techniques and try to find out the result to test the hypothesis. For example, the total quantum of crime happened in various districts in India. It varied. It varied. If you take Chengalpattu, if you take Chennai, if you take Kanchipuram, or even metropolitan city like Bangalore, Calcutta, Delhi, Bombay, the crime rate is changing over a period of time. Either it can be a decade or it can be 30 years or 25 years. If you look at the data, the numbers, the number of crime happened under different headings like theft, burglary, or murder, property crime. And there are around 15 to 20 types of crimes have been recorded in the Crime Record Bureau reports. So the reports are available for each district over a period of say 50 years. You have numbers. Each number, each cell that row and column meets, each cell will give you one information. Say one information may give you, like in Bhopal during that 1999, this much of burglary had happened. You will get one single figure, and that figure will tell you about a particular thing in a particular district. But I have data of n number of districts for t number of years. Okay, now I have a bunch of numbers in a matrix form. So what do I do? How do I answer my question? How do I test the hypothesis? That is where we need a support from statistics, because statistics is a subject which helps us to test the hypothesis, which helps us to take decision, which helps us to forecast something for the future based on the past data. Okay, fine. So now let us just begin with the quantitative approach. Maybe tomorrow let us go with little bit of qualitative approach, and based on your interest, you can proceed further. Fine. Now, assuming that you have collected some information, right? You have collected some information in terms of value, number, or some kind of a fact you have collected the information. Now, how do I compile those information which I have collected, Fine. Okay. One second, please. Jayden, just a moment. Laser image. Okay. Sorry. Okay, fine. Right now, so I collected information. I asked some, what do you mean by collecting information? I know I'm studying this, and to study these things, I need information. If I want to get that information, I have to ask some questions. I have a list of questions. So I have a list of 60 questions, 70 questions, or 100 questions. I've arranged it in an orderly manner. Then I go and meet a respondent, ask these questions, get information. through the questionnaire method, I got the information. Now, these information, if I take one questionnaire, I got 60 different information related to one particular individual. Similarly, I have collected from 500 families or 500 respondents or 1000 respondents, whatever it is. Fine, okay. Now, how do I enter this data? Right. Before going into that one, I just give you, there are, if you go to the statistics books, they will give you some names for these variables, like a scale variable, nominal variable, ordinal variable, all these things will be there. But I just wanted to give you, practically, you remember, there are only 3 or 4 types of variables which you have. What do you mean by variable? Variable is nothing but, when you ask the same question to different people, you may get different answers, different numbers. For example, what is your age? Age is a variable. So because I meet one person, I'm asking the question, what is your age? He will say 70. The another person may say that 63. The other person may say 43. So each person gives you different values. But definitely, some of the values may be also same. Suppose if I meet 2 individuals of the same age, they will give the same numbers. Doesn't matter. But overall, when I entered that age, whom I have collected, it vary. For example, income of the family, it vary. Number of cases handled by a judicial magistrate court, vary per day, vary. Okay. Number of judges available in each high court, vary. Number of law students across the various law colleges, vary. So it is variable. Okay, find it. So now these variables, I just classify into 3-4 groups. So please take a note of those things. And the definition of those variables might be available in your statistics books. You go for it. One kind of variables are nothing but we get the information, we enter the data as it is. We enter the data as it is. So simply I want to call it that as it is variable. Say like age, income, how much is the temperature today, how many cases handled, how many cases convicted, how many people are at prison for this particular point of time. Okay, so it's all, I get some information, how many COVID deaths today. I get information, I will enter the data as it is. I'm not going to change anything. Okay, right. What is second type? Second type mostly like, yes or no type questions. Are you a convicted person? Yes or no. Are you married? Yes or no. Are you an employee? Are you an yes or no? Okay. So there are some, most of the time we may include some of these questions like yes or no. Do you own a house? Do you own a vehicle? So there may be an yes or no type question. If it is yes or no type questions, here actually it is a qualitative variable. Are you have you committed any crime? Yes or no. So that reflects something like, are you owner or a tenant? It attaches a quality of a particular aspect. So here, when it comes yes or no, you attach 2 numbers for these 2 things. Yes, one number, no, another number. Okay. So it can be 0 or 1. 0 or 1. Which is to be 0, which is to be 1, I leave it to you. For example, are you married? Unmarried, I give 0. Married, I'll give 1. Have you committed any crime? I haven't committed any crime, I'll give 0. I have committed crime, I'll give 1. Fine? Okay. Similarly, which gender you are, male, female. There you may get confused. Should I give 1 for male or 1 for female? It is up to you. Right? Okay. And educated, uneducated. Obviously, uneducated is the 0 and educated is 1. Even if you give otherwise, it is not going to create any problem. And normally, a disadvantaged category will be given 0 and the other one as 1. And these type of variables, which takes which is qualitative variable, but which takes only two things, 0 or 1. We call it as a dummy variable. What is the use of dummy variable? I'll teach you tomorrow. This is dummy variable. So wherever you get two answers, you assign one as 0, the other one as 1. It is up to you which is 0, which is 1. Is it clear? So first as it is variable, the second one is dummy variable. The third one is, for example, occupation. What is the occupation? I'm asking a question. And somebody may say that I'm an agriculturist, I'm an industrialist, I'm a self-employed, I am a student, or I'm a farmer, I'm something. So I have a list of occupation, say 1, 2, 3, 4, 5, 6, 7, 8. 8 occupations are there, and they will put a tick mark for one of the occupations. Here I cannot say one occupation is better than the other occupation. I'll keep all the 8 occupations as the same thing. So now here again it is a qualitative nature. It is qualitative kind of a data. So here again I'm simply attaching, if there are 8 categories are there, I start with 1 and end with 8. 1, 2, 3, 4, 5, 6, 7, 8. So ultimately I want to enter in my data sheet only numbers. So for that I am attaching 1, 2, 3, 4, 5, 8. You may ask, sir, can I enter 27, 28, 29? You can. Nothing wrong. 27, 28. But better, I think, start with 1 to 8. It will have some advantage in it. So you may ask, sir, can I give 15, 93, 25, 76, something like that? That's not correct, actually. So it won't be nice. So there must be a kind of an order. So it is better to start with 1 to 8 or 1 to 6 or 1 to 10, whatever it is. So, but here, but that 1 is not lesser than 5. 5 is not less than 10, quality wise. So this is a kind of variable. We are calling it as a nominal variable. We are nominating one number attaching to a particular occupation. Is it clear? Right. So as it is variable, dummy variable, yes or no, and categorize, not one is better than the other. I just assign 1 to 8 or 1 to 5. All of them are equal weightage. Right. Now I go for another kind of a variable. Say for example, education, educational status. You may ask the question, how many years you have been educated? If he is a degree holder, he will say that I have been educated 15 years, plus 2, 12, and 3, 5 years. If you are postgraduate, they will say 17 years. So you can even put that number also. You can treat that as an as it is category. Otherwise, what you can do now, you can classify this education as illiterate, one group. Primary school educated, another group. High school educated, another group. Higher secondary educated, another group. Degree graduates, another group. Postgraduate, another group. Or simply literate, school educated, college educated. So you are categorizing it. So when you are categorizing it, you are qualitatively grouping them. These are all illiterates. These people are only school educated. These people are college educated. Clear? So you have 3 categories. But here again, you are going to put 1, 2, 3, but 2 is better than 1, 3 is better than 2, 3 is also better than 1. So when you go for higher number, that has better advantage than the earlier group. But in occupation, it is not like that. Occupation also, you have 5 categories. You assign 1, 2, 3, 4, 5. Here also, you have 1, 2, 3, 4, 5 categories like illiterate, school educated, primary school educated, high school educated, higher secondary educated, college educated, or college educated, 5. But there also 1 to 5, here also 1 to 5, but that 1 to 5 are equal to each other. Here that 1 to 5 is, the last number is better than the rest of the earlier numbers. So this is also nominal, but there is an order, there is a rank, so that we are calling it as an ordinal numbers, ordinal variable. So there are 4 variables only I have introduced. One is as it is. The second one is dummy, 0 or 1. The third one is you are nominating, but all of them are equal, 1 to 5. You can place anywhere, anything. But the last one is an orderly manner you are giving number. These are the only 4 categories of variables which mostly we will come across in our research. Okay, fine. So before even you go for data collection, when you type your questions in your questionnaire, you will come to know the information which I am going to get from the third question is any one of this category. Okay, any one of this category. If you want to ask them their opinion, it won't come under here. That are all qualitative variables. So mostly better to convert your questions into the questionnaire in these formats, because that will help you to go for and there are some other categories also there, like the Richter scale, strongly disagree, no opinion, agree, strongly agree. That is also again kind of an ordinal variable, 1 to 5. It is an ordinal variable. That's also belong to this one. Fine. At this particular point, if you have any doubt, you can ask me. Anyone, if you want. Yeah.
So slide is not changing actually.
No, I haven't changed, ma'am.
Yeah. Then
I'm just giving you the brief outline. Now, based on this, I'll go into that one. But this particular point, if suppose if any of the research scholars wanted to have any question, I'll give you 2 minutes time and then I'll go.
Sir, as of now, we do not have any questions. Oh, but there is one question, sir, that we just have. What is a ratio scale, sir? They want to understand what a ratio scale is.
Yeah, that's what, again, that is the same reason I didn't go into that in detail about what are the ratio is nothing but again that as it is scale only. That as it is variable also, like income. So if you take in the first group, when I have 1,000 rupees my income in 1 to 1,000 I have. Another person is 1 lakh, means that 1 to 1 lakh he is having it. Do you understand? So suppose 2 lakhs income means that I have 1 to 2 lakhs. So my ratio is higher than the earlier person's ratio. So there again, I think we are not calculating that ratio. It is basically the distance between the first value to and your value is higher than the other person, or yours might be lesser than the other person. You may be in the middle. So that is why I completely understand. Instead of me teaching that differences in that one, I just take the gist of it, and you need not worry about what is the name of those variables. Entire your data analysis, you will have only these 4 type of variables, not more than that. I think you take any question, and that will fit into this 4 variables. Okay. So that's why ratio scale, nominal scale, ordinal scale, all those things, you please refer any statistics books. They will give you clear example and all those. But to have a data analysis based on my experience, I have come here. Just these 4 items, this 4 category will capture every type of questions through which you are collecting the data. Maybe the scale variable, again, I told that Richter scale, 1 to 10 or 1 to 5 or 1 to 6. It again, some cases you will ask them to say, rate my teaching 1 to 10. 1 is lower, 10 is higher, right? Okay. So that suppose if somebody gives 5, that's 1 to 5. He has taken that only 1 to 5. Other person 9, 1 to 9. The ratio is different for both the cases. Or sometimes what will happen, they will take -2, -1, 0, 1, 2. But anyway, all those things that the positioning is different. That's all. So I think we are doing in the social science. Let us not give more importance about that accuracy of all those things. Simply, we will ask some question and we'll get information. How that information can be used in statistical analysis. For that, mostly these 4 variables, 4 kind of variables will accommodate all the questions which you have asked. Anything else?
There is one more question, sir.
Yeah.
Mr. Karnakar wants to know if data collected from Likert scales are ordinal or interval.
Can be, that's what I told you. Like, for example, how do you rate this lecture? If it is 1 to 10, that is actually ordinal. You are arranging, you are not asking 1, 7, 8, then 3, 4, 8. It is arranged in a manner so that if you give 9, you are liking this lecture better than the earlier persons. So that is right, but it is also interval kind. The thing is that 1 to 2, 2 to 3. The interval is also given at the constant level. Okay. So normally, I think it is an ordinal variable also. It is a ranking one. Yeah.
It can be both. Okay.
Yeah.
Okay. Thank you.
Okay, we'll go to the next one.
Yes.
Fine. Right. Now, okay, assume that you understood that variables which we can, and the questionnaire is there, you have collected data. And I will give you some examples. So when you open an SPSS, listen, you will get a screen like this. Those who haven't used SPSS, this may be useful. Those who already used, I think this may be a child's play. So here you look at this bottom left, you have data view and variable view. If I click variable view, you will get this kind of the name of the variable you are going to create. And there are so many other columns are also there. Here again, I want you to concentrate only on name, label, values. Again, I don't want to waste a lot of your time in teaching what all these definitions. If you right click, you will get a kind of a manual. If you go through that, you can understand because you are all doing PhD. But I think you just concentrate on name, label, values. Only these three things you can forget about decimal, width, type and all, because you are always converting into numbers. So you are going to enter only in the number. So let it be numerical. Okay, fine. So name, label, name, values. So now here, let me just take another. Could you see one general survey? Yeah. Could you see some numbers?
Yes, sir.
Yeah, right. Good. Now this actually, some researchers have already collected data. Okay, then they have entered. So now I am showing you as an example. Right? Okay. Here, let me click variable. So look at this one. There are so many variables are there. And yeah, you can see that the sex, race, region, happiness. So your variable should be as short as it is, and there should not be any space in between. Say you can't say family income, family gap income. You can't type like that because the space is not accepted in that name. So instead you have to family underscore income. That hyphen also is not accepted. So better family underscore income because when you collect data, individual, the respondent income and family income, the two things you may want to collect. So you can say income underscore RESP, respondent, income underscore FLY, it can be family, right? Okay, expenditure also can be similar to that. So here you could see that there are around 43 variables are here. 43 variables mean 43 questions are there. 43 questions you might have asked into that one. Now look at that label. The sex, respondent sex, region of the United States, happiness, general happiness. Okay, now come to this. So this label is nothing but the description of what the variable is. The variable name is as short as it is. Okay, as short as possible. And that short format has to be explained very clearly. Say, for example, if I put FLY, family, underscore INC, income, FLY underscore INC, that is my variable representing family income. So here in the label, I will type family income. Immediately, somebody will ask, sir, is it monthly or annum? So then I have to add family income per month. Then somebody will ask, sir, is it in rupee or is it in thousands of rupees? Or is it in lakhs of rupees? Then I have to write family income per month in thousands of rupees. So the one which I type here should not allow anybody to ask question about what is this variable is about. What is this variable is describing. Okay, clear? So the label is the one which we are going to tell the the reader what it is. Okay, and also this will also display in your result. So when you take result, when you print that result in your articles, this will give a clear picture about the reader what this particular variable is about, right? But now we are coming to that important things, values. Say this general happiness. Okay, the general happiness. The question here is, are you happy? Are you happy, right? Are you happy? So this is a general survey about, say now some of my students are also doing after COVID, how the life is about. How is the life in rural and urban? What are the difference? And different segment of the population, how the life is after COVID. They're doing a survey. So the basic question they ask, are you all happy after the COVID-19, where it is coming down, so that you may ask the question, are you all okay? Are you all happy? Something like that. So I gave some answers. The answer here is, look at this one. Yeah. So one is not applicable. So I have assigned some numbers. So I have nominated some numbers. 0 is not applicable. 1 is very happy. 2 is pretty happy. 3 is not too happy. 8 is don't know, DK. 9 is not available. Not available, not applicable. Not available is different from not applicable. Say, for example, you are asking a question, have you been convicted? The answer is no. If suppose if you ask the follow-up question that how many years you have been in prison, it's a not applicable question, isn't it? Only when he say yes, I am convicted, then the next question is applicable, right? And similarly, don't know also may be there. So what do you think about the present government in combating COVID? I don't know. I can't say that they are good or they are bad. So they have the right to say, I don't know. And not available means they are not available. When we went there and we asked get the question, get the answers, they are not available. But mostly in our Indian research case, we don't consider this not applicable, don't know, and not available. So we mainly concentrate as 1, 2, 3. But if you need, you can include nothing wrong, nothing wrong. Okay, fine. So here you can maybe I'll just create one variable and show it to you how it can be done. So for example, I just create education. Okay, education. Okay, here label is education of okay, educational status of the respondent. Okay, fine. Education. Now I go to value. Okay, here if you in the blue thing, if you click, you will get to the, so value 1, I'll put there illiterates. Okay, add. Then I put 2. I'll just type there school educated. Okay, then add. I'll put 3. Then collegiate educated. Collegiate. Similarly, you can add any number, right? You can add a 4th professional education, something like that. So when you give OK, you can see that the variable is created, and when you go to data view, only one variable name will be their education I have created. So here you can enter fully the education of the respondents. So now you can see that one column representing one variable related to all respondents. Suppose if you have collected 600 respondents, in this column you will enter 600 values. Okay, right. This one row is related to one respondent. This one column is related to all respondents. One row is related to only one respondent. You take a questionnaire and enter all the information in the first row, keep it away. Take the second questionnaire and fill it up all the rows. So now it is very easy for you. So even while you are collecting data, that night itself, you can enter the data. Or sometimes you can take your friend, and when you are asking the question, that friend can enter the data here itself. Straight away he can enter. It's not like early period where we used to struggle to enter the data like this. Now it is on your palm, you can enter the data. You can even construct the questionnaire and link that questionnaire with this data. So the moment you click or write something, it will automatically go there. Fine, right. So assume that you have entered the data here and look at the data view. So this is the data view. So how much of data is there? You can see that. You can see that. (1,517) 1,517 respondents have responded to the question related to the general survey of life after COVID or before COVID, whatever it is, or in general. And how many variables are there? 44 variables. So what is your data matrix? Your data matrix consists of 1,517 row and 44 columns. 44 columns. Is it clear? Right? So for your data also, for your study also, you can enter as many as row based on your respondent size and as many as column based on the number of questions which you have asked in your questioning. Is it clear? So now our data matrix is ready. Our data matrix is ready. Now what do we do? That is the question. So this is the data matrix, data platform for our research. So once if you reach this stage, I think almost half of your work is over, whether it is PhD or your paper writing. Okay, fine. Now we have to go for data tools. See, when you say tools, n number of tools are available, starting from frequencies, percentages, graph, then chi-square analysis, t-test, ANOVA, f-test, then one-way ANOVA, two-way ANOVA, MANOVA, then regression, correlation, partial, multiple, dummy variable analysis, logic, probit, SEM. So a lot of models are available. Models are nothing but, you design that this is the variable and I am going to enter these variables, these data is used for analyzing this model. It may be a multiple regression model, it may be a SEM model, it may be a path analysis, it may be a factor analysis, it may be a cluster analysis, it can be any simulation. So many things are available, and the only problem here is because of the invention and availability of the packages like SPSS, eViews, Stata, and so many other packages, AMAS, and are so many things. It's just like a child's play for the researchers to enter the data, use that SPSS or whatever it is, get the result. But the question is, how do I interpret? Before that, the first question is, which tool, which statistical technique I have to take it, which statistical technique I have to take it for my research. That is the big question. For that, I think basically you might have done some statistical course at your undergraduate course or even the postgraduate course, even in research methodology also, you might have given a taste, a pinch of, kind of an introductory statistical things to it. So basically, you have to create an interest. You have to create an interest, and based on that, I think you can go for create knowledge, and you can use it for that. Right now, the baby step for any researcher is to go for a frequency table. Frequency table, right? Okay. So let me also show you how to take a frequency. Though it is a very simple, very easy thing, but we should start with this one. So let us, those who wanted to take a notes, please take a note of it. How do we go about the frequency table or descriptive statistics? Are you with me?
Yes, sir.
Okay, fine, right. So just start with analyze. Could you able to see that? Analyze. And descriptive statistics, frequencies. Are you able to see that? Analyze,
Yes.
descriptive statistics, and frequencies. You just click. Okay, right. And you need not put all these variables. The variables list will be here. You need not put all these things and select here and do it. It's difficult. So I'll select some variables. Say, for example, general happiness, I'll select and put it here. And also I'll go with that occupational category. Okay, I'll take occupational category and put it here. So two variables I have chosen. And if you want to get some statistics related to this, you can choose that statistics option here, and you will get lot of statistical indicators like mean, median, mode, sum, standard deviation, variance, skewness, kurtosis. It is basically based on what is your expectation, what you are trying to prove. So you may try to prove that in the urban area, the distribution of income is more skewed than the rural area. For example, expenditure on the legal expenditure. Okay, and you try to prove the legal expenditure is the mean average legal expenditure is high in urban courts compared to rural or the second tier district schools. And not only the average expenditure, the distribution also very high. And that distribution can be measured with the help of kurtosis and skewness. So if you want to focus only on that, I just wanted to know the legal expenditure of a particular type of cases, maybe divorce cases, right? Or some other cases. You know the better thing. So the average is also higher in urban, and the skewness is also different. Distribution is also different. You want to prove means, then you can choose the skewness kurtosis, a mean, median, mode, whatever, median. Then do that. But here we don't want to do that one. And then go to charts. So if you take charts, you can click bar chart or pie chart or histogram, whatever it is. I just take that bar chart. Okay. And then continue. Right? So I've chosen two variables and place it into the box of variables. And I just go to charts and I chosen something. Give OK. You will get a result. Could you able to see the results?
Yes.
Yeah.
Yes, sir.
Look at that result. This is we are happy. We are little happy because we are able to compile. We are able to compress. We are able to compress the, you might have collected 1,517 respondents. So what we are giving here is the compressed result of the 1,517. So this is a kind of an amalgamation, a kind of an accumulation of this. So what is this here? What these numbers are speaking about? I have three categories: very happy, pretty happy, not too happy. I ignore that don't know and all the case. And here 467 responded out of 1,517. 467 out of 1,517, which constitute 30.8%. But when I compare the percentages, this is the highest percentage. So I can say pretty happy. Most of them are very happy, pretty happy. And if you put together these things, it is 57 plus, 57 plus 30 is 89. So this is a cumulative percentage up to 89. So 89% of the people are either very happy or okay, pretty happy. Now, how many of them are not happy? Again, 11%. 11% are there. Now, what is the difference between percent and valid percent? Percent and valid percent. Because here, the denominator is 1517. But here, the denominator is 1504 because the 13 people were not responding. They didn't respond. So that why should I include that in the total case? Not necessary. So, for example, in a class, right? Okay, in a class, if there are 60 students are there, okay, the your dean wanted to know in a particular batch how much is the average of a particular paper. So you will collect information about the marks, add everything, divided by 60. You will say that it is, sir, they've got 73%. But out of 60, 5 students were absent. For those absent students, you might have given 0, 0, 0. Absent students, you might have given 0, 0, 0. So, which case, the total 55 marks added divided by 55 will give a better result than adding all the 55 divided by 60. So, the denominator should be 55 rather than 60. So, similarly, the denominator here should be 1504 rather than 1517. So, if you take that, it is a valid percentage. So, better you take the valid percent as one, so you can delete this particular thing. So, now how do I delete this, sir? Can I delete this here? No, you can't touch anything here. So, what you can do, you can select this one, right click, copy special, and just, okay, copy itself is enough. So, right click, copy, then open a Word file, click a Word file. Here, right click, paste it. Yeah, are you able to see this?
Yes.
So it's
Yes,
very
sir.
simple. In the SPSS output, you cannot do any alteration. So whatever you want, you just click, that particular portion will be encircled, and it will be, you can right click, copy, and come here and open a Word file, paste it. And here you can do whatever you want. If you want, you can just remove this, you can easily delete it. Yeah, you can delete, you can even remove that thing, and you can alter this table, alter this topic title, and here you can give the title of the chapter, title of the table. Here you can give your source. You can explain this, what is this about this. So, which means, and you can even also bring your, this one, like graph or a figure. So it is very clear that pretty happy is more. It's kind of a symmetrical one. So some people are not happy, some people not much skewed one. This is occupational category. This says in this particular category, technical, sales and administrative is very higher. Farming is very low. Farming is very low. This is related to US. Suppose if you do it in India, this farming will be very high. This farming will be very high. So clear? So this also you can right click, copy and paste it there. Fine. Now, my question here is, participants try to answer. There are two variables I have shown you. There is a variation because not everybody is having equal amount of weightage. Because even if you look at this 2% is one category and 32% is in another category. So there is a variation. There is a variation here. There is a variation here. Now I just wanted to see the variation in opinion about life. The variation in general happiness is anyway associated with variation in occupation. Can we try to prove? Can you try to do something by bringing these two things together? Is it possible? Or could you see that is there any association between these two variations? Yes or no? Hope all are you with me? Hello.
Yes, sir. Sir, in the chat box, the participants are saying yes.
Yes. Okay. Right.
There is.
Yeah. Good. So there is a possibility of some kind of an association between these, which means that variation in one variable may be influenced by or may be influencing a variation in the other variable. Occupational distribution may be causing the opinion about the life. Right. Now, how do I prove this? How do I prove this? So the first thing is here, I just wanted to set a null hypothesis here. I just wanted to set a null hypothesis. What is the null hypothesis? H naught. H naught. There is no association between happiness and occupation. Okay, I'm just setting a null hypothesis that there is no association between happiness, distribution of general happiness, opinion about happiness, and occupation. This is the null hypothesis. Alternative hypothesis is obviously there is. Alternative hypothesis obviously there is. So now, how do I test the hypothesis? How do I test this hypothesis? That is the question. How do I test this hypothesis? So for that, definitely there is a possibility of using some statistical technique. Okay, that statistical technique is nothing but called chi-square analysis. Chi-square analysis. Okay. I don't have. I mean, if it is a physical class, then I could have taught you something, about sampling distribution and so many other things. But now it is a virtual one. I don't have a virtual board so that I can't do that. But anyway, I'll try to make you understand what it is. So I'll select the chi-square analysis, which will always help us to test the association between two qualitative aspects. Here, one qualitative aspect is occupation, another qualitative aspect is like opinion about the life. Now, these two things are associated. I'm not saying that this is causing that or that is causing this. Okay, I'm not saying that. I'm just saying that both of them, or the variation in both of them, may be associated. So now it is our job to prove yes, it is associated, no, it is not associated. And so we set the hypothesis. So when we are setting the hypothesis, we always start with the null hypothesis. Null hypothesis speaks about no relationship, no influence, no association, no difference between before and after. The difference is zero, something like that. We always try to say it is not there, and then by rejecting that, we will prove yes, it is there. Okay. Sometimes we will accept that also and say that yes, they are not related. Say, for example, rainfall and the marks scored by you, are they related? You may say that yes, sir, because of the rainfall, there is no power, there is a power cut. That's why, and we don't have a candle so that I couldn't read. That's why I didn't get marks. You can go around and say that. But it is not the fact. Okay, so there may be a direct relationship. We have to check whether there is an association or not by taking this. So now take a note of it. How do we apply chi-square analysis through SPSS? Okay, fine. Go to analyze, descriptive, cross table. All the other things you can better learn by yourself, right? Analyze, descriptive, and cross table. So the moment you go for cross table, there are two things. One is row, the other one is column. So in the earlier case, only one variable is considered. Now we are considering two variables. One in the row side, the other one is in the column side. So the row side, I take occupation. I take occupational category as the row side horizontally. Then I'll take this general happiness in the columns. So occupation, there are 6 occupationals are there, 3 opinions are there. So 6 into 3, 18 boxes will be there. Okay, from left hand side, if you move, 6 boxes will be there. From above, if you come below, there will be 3 boxes. So 6 into 3, 18 boxes will be available. Right? Now, with these 18 boxes, what do you want to fill up? Go to statistics, click this top left chi-square and continue and go to cells. I repeat, go to statistics. On top left, there is one chi-square, click and then click cells. Within this, you go to this percentage and click row percentage, column percentage. There is no need for total percentage. Okay, only these two. Click statistics and click chi-square. Go to cells, row percentage, column percentage. Okay, right. Maybe if you want, you can go this also and just click OK. You will get the result. Could you able to see the result? Could you?
Yes, sir, it's visible.
Okay. So now you can see from left hand side, if you move to right hand side, there are 6 boxes: managerial, technical, service, farming, precision, operation. From above to below, very happy, pretty happy, not happy. So 18 boxes are there. In each box, there are 3 values are given. What are these 3 values? This 131 is nothing but among the managerial economics people, very happy, there are 131 people who have said. Or in the total very happy of 441, then I think 131 people are from this managerial group. So managerial to very happy or very happy to managerial group, we can say. So this 38% can be calculated that Out of 337, 131 is 38%. Out of 337, 176 is 52%. Out of 337, 30 is 89. So if you add all these three percentages, you will get 100. Similarly, out of 441, 131 is 29%. Out of 441, 139 is, so this is row percentage, and this, everything is column percentage. If you add that, that is also 100%. Okay, so totally 1,407 people have been considered here. So this is your cross table. You are bringing one upon the other one, and you can right click, copy, paste it in your Word file, and each number. So 18 into 3. 18 into 3 means 54 numbers are here. You need not interpret all the 54 numbers. You can take the lowest, highest, and your the value which you interested to explain. You can write a paragraph or two about it. See, one important thing I wanted to say, research is not simply getting this table and interpreting this number. Okay, research is not simply getting this table and interpreting this number. Beyond that, you must definitely answer why a particular thing is low. What are all the reasons for farming is very low here? Or why in farming group, most of them said they are not very happy. What could be the reason for that? So identifying the reason and connecting with this table interpretation is nothing but the research. Okay, it's not simply copying, give a title, or you can even go for a chart like this, a clustered bar chart, and write about that number. That is not research. Research is you must identify the reason, causes, factors, and the reasons. Understand? Okay, fine. Now, the good thing here is, yeah. Right. Now, sir, you have set a hypothesis. What is the hypothesis? There is no association between. There is no association between two things, two variables, which means I am saying that there is no association between opinion about the life and the occupational distribution. Occupational distribution nothing to do with the opinion about the life. Okay. So that has to be rejected or accepted based on chi-square value. And in your statistics class, your teacher would have taught that you apply the chi-square formula, summation of OI minus EI whole square divided by EI, and get that calculated chi-square value, and go to the big statistic book. The last pages, you will have chi-square table. Choose 5% level of significance. What is the chi-square table value? Compare the calculated value and the table value. If the calculated value is greater than the table value, reject the null hypothesis. Otherwise, accept. This is what would have been taught by your teacher. Understand? But now, with the help of computer and the packages like SPSS, there is no need for us to calculate chi-square value, go for the table value, comparing not necessary at all. It automatically gives you this chi-square value. Look at this one, Pearson chi-square 26.94. This is the calculated value. Table t value, no need to calculate. Instead, you concentrate on the sig value. Very, very, very important thing in these two sessions. Because the sig value, most of the researchers be worried about. What is the sig value? The Greek and Latin. Why do I do this one? What is this? Why researchers are giving more importance to this sig value or p value? So this sig value is very, very important. And this sig value will help you to accept or reject the null hypothesis. Okay. Now, in this stage, I will give you 4 rules of hypothesis testing, and there I think you can yeah. One second. Would you be able to see this rules of hypothesis testing?
Yes, sir.
Okay, all of you, please give me 2 minutes rest so that you can write by yourself. Don't take photo. Please don't take photo. Write by yourself in your notebook. Slowly read and write this, because this is the key one for any research. Please read it slowly. 2 minutes, take your time. Jayvel. Jayvel. The R and Tandir, yeah. Once you finish, you give me an indicator. Have you all finished?
Yes, sir.
Okay, good. Very good. This is the rule of hypothesis testing. Maybe I'll take just say 5 minutes for explaining what is this significance level and confidence level. Okay. Actually, if it is a physical class, if I use the board, it'll be more effective. But anyway, just I'll try to convince you as much as possible. See, let us take, for example, okay, Chief Minister wants to know in a particular area. Let us take Tambaram. Okay, let us take Tambaram. Chief Minister wants to know how much of crime actually taken place per month. I think this example may not be suitable for this. I'll go with another example. Okay, what is the average earnings by a lawyer? per day. Let us take that because it is related. What is the average earning by a lawyer per day in a particular area? Tambaram. Let's take Tambaram Court. Okay. Assume that there are n number of lawyers are there. N number of lawyers are there. Okay. Now the question is, how do we find out the answer for this one? In general, let us not take only Tambaram. It is in general. What is the average? What is the average income of lawyer per month? Lawyer per month. Okay, in general, in Tamil Nadu, let me take it in Tamil Nadu. Now, we want to have the answer as soon as possible. As soon as possible. So now, how do we get this information? One way of doing this is take the list of lawyers in Tamil Nadu. Okay, n number of lawyers are there. It's very difficult now to know that. Maybe Bar Council of India will give you, but it's very difficult because somebody is added and somebody is deleted something. So it's a huge amount of people are there. Huge amount of people are there. So it is very difficult to get the information from them. And again, we do not know whether it is what kind of mechanism to calculate that amount also. And because there is no record into them. So there is an exact figure that if you are able to get information from each and every lawyer who are working in Tamil Nadu and add everything divided by number of lawyers, you will get one figure. You will get one figure. And that is the value. That is the value. Let us assume that it is, say, simple. I'm just giving you, it is 70,650. 70,650. Just I'm giving one figure, which may be less or more. I am not going to that. That's one figure is there. So that is the average value. That is the average value, 70,650. How did I get it? I am able to get information from each and every lawyer who is in Tamil Nadu, get the information about their monthly income, add everything, divided by that many people, I got this value. That is a true answer. That is a true answer. So let me represent that true of something is equal to one symbol called mu. Just symbol called mu. The name like your Delta coronavirus, something like that is mu. Now, is it possible to get that exact value within a short period of time? Or even if it is a long period of time, it is very difficult. Okay, you can't meet them and you can't get them. You may ask, sir, why don't we get it Bar Council circular and get it there? It's not possible. And we don't know. So now what do we do now? We'll go for a sample. We'll go for a sample. Assume that there are 50 participants are here or 100 participants are here in this workshop. So I am giving you the task of giving the answer for them. So the first participant will go and select some sample of lawyers, get the information, add everything, divided by that many people. He will come with one answer and he will say that, sir, my survey, my sample says that it is 80,000 plus something. The next person say that, sir, my sample says that 63%. Another person will say that, sir, it is my 1 lakh. So I get 100 answers. Hope all of you are with me. Participants, please listen. Because this is where I think you can understand this confidence and significance. 100 answers I have. 100 answers I have. Because 100 participants give me, because each one of the participants are representing different region. So they just try to collect as much as possible data and they told me that this is 100 values are there. But listen, the original value is 70,650, but I don't know that one original value. I'm just telling that mu. Instead of that, I say that mu is one true value, but I don't have that value because I didn't do that exercise. If I had done that exercise, these 100 people, I could have not asked to do that. But there is one value is there, that is mu. And each one of you are telling this, sir, my value is closer to that mu. Another one say that mine is good, closer to that. But as long as I don't know that value of mu, I may not able to say that this is closer to that or that is closer to this. Right. But all of you are genuine and all of you are genuinely selecting the sample, covering all the region and collected the data, add everything, divided by that many and get it. So now what I do, please look at the beauty of the statistics. all these 100 results of the mean income of lawyers, I will arrange it in an orderly manner, an increasing order or decreasing order. So starting with the lowest one and go with the highest one. So now the 100 values are arranged in an ascending order, lowest to highest and this one. So this is called sampling distribution of the statistic. Mean, which is nothing but mean. When I say statistic, there are so many things are mean, standard deviation, so many things are there. And this is the sampling distribution of a statistic called mean. So I have 100 values. Okay, clear. Now, with the past, over the period of 100 years, lot of legends, statisticians have tried again and again with experiments, and they have proved a theorem called central limit theorem. And that central limit theorem says that if you have enough samples and got the results and construct a sampling distribution of that statistic, listen, look at carefully, mean of this sampling distribution will be equal to the true mu. Mean of these sampling distribution will be equal to the true mu. That is one thing. Second thing is, the second one is standard deviation of this sampling distribution. If you want, you can take a note of this. Standard deviation of the sampling distribution of a statistic. I repeat, standard deviation of the sampling distribution of a statistic is known as the standard error of the statistic. Standard error of the statistic. Okay, right. So you have, the sampling distribution, and you are very clear that standard error can be found out. So now the beauty of the statistics is, please listen, you are 100 people are there, right? I take any one of the person's value. I take 43rd person. 43rd person's result plus or minus. One time I take plus, the other time I take minus. So the 47th person's result plus or minus 1.96 time of the standard error. I repeat, 47th person's value result plus standard error of that statistic or minus the standard error of the 1.96 time of that statistic. I get one range. Because if I apply minus, I'll get the left hand side value. If I add plus, I'll get the right hand side value. So instead of one single number of that 47th value, I get 47th value minus something, 47th value plus something. That something is nothing but 1.96 time of the standard error. Remember, this range I have, out of 100 of your values, 95 values will be falling within this range. Is it clear? Which means I am 95% confident. I am 95% confidence that the true mu value will be within this range. So I am not giving one single number. I am giving a range, but I am making a confidence statement. I'm making a confidence because without this, I cannot say that 47th person's value will be closer to mu or the another person's value is closer to me. I can't say a probability set, but now I can say anybody's value out of your 100 people are there, anybody's value plus or minus 1.96 time of the standard error, I will get a range, and within that range, 95 your values will be where? When out of 100, 95 values are falling within that range, don't you think that that unknown mu, that true parameter value will fall within that range? It will. I am 99% confident. Suppose instead of 1.96, if you multiply it by 2.33, you will get 99% confidence because you will get a wider range. out of 100 values, 99 values will be falling within that range. So that is what confidence level. So 1 minus confidence level is equal to, or 100 minus confidence level is equal to level of significance. So now you read, if sig value is less than 0.01, we reject the null hypothesis at 1% level of significance. This means that I'm 99% confidence. So you are telling that result, you are interpreting that result with 99% confidence, only 1% chance of falling outside the region. The true value falling outside the region, how many percentage is there? Only 1%. So that is level of significance and 99% confidence. So if it is 1% level of significance, 99% confidence. If it is 5% level of significance, 95% confidence. If it is 10% level of significance, 90% confidence. So maximum you can allow 10% to be away from that range. And you must have at least 90% confidence to say your result. You cannot say, sir, I have 80% confidence, I am 73% confidence. No chance of saying that. So don't ever reject the null hypothesis with less than 90% confidence. So the only chance is 1% level of significance, 5% level of significance, and 10% level of significance. But if by default, you can go for that 5% level of significance and 95% confidence. And anything greater than 0.10, anything greater than 10% level of significance, you have to accept the null hypothesis and say that there is no association. Any doubt in this one, please? We have another 10 to 15 minutes. Any other doubt?
Participants, if you have any doubts, you can.
You can even open the, you allow the mic also to be.
Yes, sir. Yes.
Unfortunately, we don't have a board, otherwise I would.
Yes, sir. Yes, sir. Yes.
So they're all saying that it's clear.
Okay, if it is clear, then very good. I think which means that they are all good in this one, statistics. Fine. Okay.
Excuse me, sir.
Yeah, please.
Sir, actually, in the social sciences, the significant level is normally calculated for 0.05 marks.
Yeah.
You have mentioned 0.10, that is 10%.
Mr. Ganesan, not necessarily. Yes. Whether it is social science or any science.
But
in level of significance and the confidence interval are complementary to each other. Okay. If you want to set, one second. Sir, now webinar look, sir, 10 minutes. Okay, fine. Right. Okay. Yeah. I'm resource person, sir. I just. Okay. Okay, listen, Dr. Ganesan, or the person who asked the question, whichever discipline it is, statistics is very clear. You can make at 1% level or 5% level or 10% level, not more than that. That's all. It is up to you to use it, any one of this, or you accept the null hypothesis. That's all. There is no question of whether it is social science or physical science or whatever it is. But mostly by default, it is 5%. By default, it is 5%.
It's correct, sir. But in the previous session, Professor Kannan pointed out that normally the science faculty they used to go for 0.01, whereas the social scientists they used to go for 0.05.
Yeah, that's a nice approach. But my point is that statistics gives you a scope. Whether you take it or not, it is up to you.
Yes, sir. Yes. I've never seen for 10%. That's what just I want.
There is always, even in 1987, in my MPhil thesis, I have used 10% level of significance with 3 stars.
Okay, sir. Thank you.
So you could see in so many cases. My point is that your argument will be based on that.
Yes.
See, I told you, the statistics is getting the result. Yes. Interpreting that number with level of significance confidence interval is fine. But after that, you are trying to justify that answer. That is where our effectiveness is there.
Yes, sir. Thank you.
Okay, but nothing wrong. You can say that 10% level of significance with 90% confidence, because you are keeping your bar very low and saying that I am only 90% confidence about my result. Nothing wrong. That's what my feeling. But as Kannan sir says, if you say that 5% level of significance is a much better one, you can say it's 95%. But unfortunately, now the recent trend is people started saying that I am 14% confidence, 14% significance. And last week I attended one PhD Viva, one of my friends' candidate. She said that no, I am 14% confidence, 14% level of significance. I said complete nonsense it is.
But whether it is internationally accepted, sir?
Whether
it is internationally accepted 14% or 10%?
No, you cannot. Nowhere in the world you can go maximum up to the 10% level significance only. Yes. Rejection. Acceptance is fine. 14% means you are accepting the null hypothesis.
Yes, sir. Thank you, sir.
Rejection is only at 1%, 5%, 10%. That's all. 11% means you are accepting the null hypothesis. Clear?
Yes. Thank you. Thank you.
Right. Good.
So I have a question, sir. Dr. Ramani, sir.
Yeah,
so the table which we were putting, sir, so we calculated the chi-square results for the two variables. So based on the result, can you just give an example of what is the results we have arrived? At what % level the significance it is showing?
Yeah, that's what. Look at this, ma'am. In the table which I am showing it now, it is 0.003.
Okay.
So now it is less than 0.001.
Less than 0.00.
Less than 0.01, right? So the first category.
First category. Okay. It is
you are rejecting the null hypothesis. You are rejecting the null hypothesis that there is no association. So you are coming to the conclusion that there is association. Okay. There is association between the opinion by the candidate and their occupation.
Yes, sir.
That's all. But you cannot go beyond that and say that occupation is influencing this or this is influencing that. You can't say that.
Yes, sir. Yes, sir.
You can say only simply that there is an association. They are related. That's all.
At this level
of regression, you can say that there is a cause and effect relationship. Yes. Good.
Thank you.
Okay, fine. Right. So now, chi-square analysis is a very good one, and by which you understood that how the statistical significance test can be done. This is for entire any analysis you do it. This 4 mantra is there. So you can use this for accepting or rejecting it. Fine. Okay. Now let me just go for another one. Yeah. Let me show you another data. Could you able to see the data?
Yes.
Yeah, fine. This is a data related to the people working in IT sector. Okay, working in IT sector. Gender, and maybe I'll show you the label. So when you read the label, you can see current salary, beginning salary, and the minority clarification is given here, like S or no. S is 0 is no, 1 is S. Right, employee category, you can see that there are 4 levels. One is clerical, custodial, and manager, right? Okay. I'm sorry, I'm not using much of your data because I don't have that data. But here again, you can use it in the police force. You can use it in the police force or judicial category. You can take it like whatever it is. Now, here we wanted to test some hypothesis with the help of this data, and there are around 500 respondents are there. Maybe you can see that. There are 474 respondents have been responded to this one, and we have collected the data. Okay. Yeah. See, here I wish to teach some t-test. I wish to go for some t-test. See, in the IT sector, there are always there is a, for researchers, try to prove or disprove certain claims. Prove or disprove certain claims. So, for example, there is a claim by a particular by the judicial ministry that these kind of cases we will settle it within 3 months. Okay, we will settle a particular type of cases within 3 months. So they have a claim. They have a claim, right? Okay. Or per month we will we will handle this many cases. There is a claim. Or I'll give you another example. Like a Hero Honda motorbike. Give a full page advertisement and say that if you buy our vehicle per liter, you will get 85 kilometers mileage. It's a claim. Fair and lovely. If you use this one, within 45 days, your face will become like a rose. They are claiming. Our Manreka scheme, government is claiming we are giving 150 days work per year, or 150 rupees per day. They are claiming. So claims are there. So now as a researcher, you want to test and say that yes, what the government says is correct, or no, they are not correct. Right now. So now how do we test those kind of questions with a null hypothesis? The null hypothesis, okay, let us take this example. Can any one of you answer the question? Suppose some of your brothers or sisters or even children would have joined in the IT sector. Tell me, what is the beginning salary for an IT sector employee? What is the first month salary of the IT sector employee? Any answer? $40,000. 15,000.
15, sir.
Yeah, 15. 10,000. 18,000. Okay, fine, good. So it is a variable. It ranges, right? Okay. So now let us set one. Somebody said 10,000. Somebody said 40,000. So the average I take 25,000. Okay. 25. I want to check the null hypothesis that mu, the average mean salary for a beginner is 25,000. Right? Okay. I've collected information. See, basic salary. I've collected information here. I've collected salary beginning is here. This column. Hope you are able to see the cursor. This is the beginning salary. Now I want to test whether it is 25,000 or not. What is my null hypothesis? H naught mu, the average mean salary is equal to 25,000. Okay, what do? I go to analyze, take down, analyze, compare means, take down compare means, and go to one sample test. Take a note of it, which will be very useful. Analyze, compare means, and one sample test. I click. And what is the testing I'm going to do? Beginning salary. Here you can put lawyer's salary, lawyer's income, how many days of court it takes to finish a case, or how many days the police station to, police people to catch a hold of that thing. You can do it. So this is the test variable. Or how many cases registered per day, how many accidents happen during that particular day in a particular region. Okay, now what is the test value here I have to type? I will type 25,000. I typed. Is it clear? Any doubt here? No doubt, right? I just put that variable and then put the test value and just give OK. Could you see the result? Yes. You see the result?
Yes.
The result is 17,000 something. The mean value for 471 is 17,000 something. But this 17,000 something is different from 25,000, obviously. Okay. But always we have to reject the hypothesis based on the sig value. What is the sig value here? 0.00. Whenever it is 0.00, please take note of it. It is an important hint for you. Whenever you see 0.000, don't ever consider this as zero level of significance and I am 100% confident. If it is 5% level of significance, you are telling 95% confidence. If it is 1% level of significance, you are saying it is 99% confidence. So that don't ask me, sir, I am seeing zero. So can I take this as 100% confidence? No chance, because there will be somewhere there is one is there. It is 0.00001. So please take a note of it. Whenever you see 0.000, you treat that as 0.001. Stay with me? 0.00 should be treated as 0.001. So that again it is 99% confidence only, because in statistics there is no question of 100% confident. 100% confident only when we can say the sun comes from east, something like that. So that is not a questionable one. So anything questionable in statistics, you can be maximum 99% confidence. So there is no question of 100% confidence. So here we are rejecting the null hypothesis because as we are rejecting, am I right? We are rejecting. What is the null hypothesis? It is nothing but 25,000, right? Now let me just go for, instead of 25, let me put 17,000. Let us see what is happening. Let us see what is happening. So instead of 25,000, I put 17,000. Somebody had given 18,000. Yeah. Look at that. What is the confidence level here? Sig value 0.96, which is greater than 0.10. So that I am accepting the null hypothesis. I am accepting the null hypothesis. Is it clear? So there is a claim. And the claim to test or to approve or disapprove, I collect information and place it in one variable and apply this one sample test. Apply this one sample test, and this one sample test, I am accepting the null hypothesis. I am accepting the null hypothesis. Sir, you may ask the question, sir, 17,000 and 17,100, there is a difference. 17,000 and 17,000 something, there is a difference. Can't we take that difference? Sometimes what will happen, there may be difference between two numbers, but the difference is equal to 0. We may consider that as 0. For example, you go for buying a washing machine. Okay, go for a movie, let us take, at the weekend. At home, you decide that, if the ticket is 150 rupees, we can buy and watch. So you're going there, and the ticket says it is 160 rupees. There is a difference, but will you come back? No, you will watch the movie. So which means 10 rupees is equal to 0 there. 10 rupees is equal to 0 rupees there. Okay, you go for buying a washing machine. You have budgeted that 23,000 rupees. You go there and it is 24,000 rupees. Will you come back? No, you will buy. So there 1,000 rupees is equal to 0 rupees. The 1,000 rupees is difference, but the difference is not significantly different from 0. Okay, you wanted to go for buying a house and your plan is 40 lakhs and the buyer says 45 lakhs. Then finally he agreed for 42 lakhs. Will you not buy the house? You will buy. So the 2 lakhs is equal to 0 rupees there. So there is a difference, but it is not significant difference. So significant difference is different from just difference. So these two numbers are different, but they are not significantly different from 0. But in the opposite case, there may be something like this. There may be a case of you have this PDS shop. I think most of you might have gone there, ration shop. In ration, now, wheat is being sold at the rate of 7 rupees 50 paise. Maybe check it, I am not very sure about it. 7 rupees 50 paise is per kg in ration shop for wheat. Now tomorrow, suppose if our Chief Minister Stalin increases from 7.5 to 8 rupees, will the public accept it? They will not. Or now there are 20 kg rice free. Tomorrow if Stalin says, let us just charge 1 rupee per kg, you pay 20 rupees, will the opposition parties keep quiet? So here, even that 50 paise is matter. 1 rupee is a problem. Okay, 1 rupee is not equal to 0, but there even 1 lakh rupee is equal to 0. So in statistics, I think there is a possibility of always talking about statistically significant difference rather than just difference. So here the difference between 17,000 and 17,000, little bit of something, is not statistically significant. Okay, so this is one sample test. I'll go to the rest of the test tomorrow. Fine. Okay. Any doubt here, please? Maybe last 2, 3, 5 minutes. If possible, I think you open up your video. Let me all see who are all the participants. Most of the time, this request will not be accepted.
Yes.
Yeah. Good. So you're free to ask question. Maybe I'll give you just another 5 minutes. tomorrow we'll see that rest of the 2 t-tests, ANOVA, correlation, regression, and all the rest of the things. How many participants actually, Sonu Mehta?
So we have around. So we have it here as well as in YouTube, sir. In Cisco WebEx, we have 190 participants, sir.
190. Oh, so who are all they actually? All
So now 262 participants, sir.
Oh, good, great. No, who are all they? They are all from your law background, or?
We have people from various backgrounds, sir, but
Okay.
also law. A lot
From
of
all
people.
over India.
Yes,
From
sir.
all over India.
Yes.
Oh, great. I thought that it is only for your research scholars. Bhagavati madam didn't inform me that.
Yeah, I'm here.
Fine. Okay, ma'am.
I have given that online national workshops, sir.
Very good, ma'am. Very good. Thank you for allowing me to reach more number of people. And now the questions. Tomorrow sharp 10 o'clock we start. 11:30 we finish.
Yes.
So
Any queries from audio participants?
yes, ma'am. There's one query. Mr. Mohan Kumar has a request, sir. He wants to know if you can explain dummy variable one more time.
Tomorrow, definite.
Okay.
Definite.
So I think it's our absolute pleasure that we had you here today, sir, because
Thank you.
I believe that in the beginning when I was explaining how you've been teaching economics for the last 30 years and you've been the head of Department of Economics and Dean of Humanities as well.
Yeah.
So it's amazing to have a person who's been adjudged as the best teacher of economics in Tamil Nadu for 2020. And you've also been served as a nominated member of Bar Council in the member of inspection committee to approve humanity courses. And you've also conducted more than 50 workshops on data analysis, sir. And we could, I think we will all agree that we were blessed to have you here because it was exceptional, sir. We were able to understand. I, for the first time, saw SPSS, and it was very, very clear and it was very cogent. So thank you so much for putting in the time and effort and for connecting with such a huge audience who really enjoyed. As you can see, the chat box is flooding, sir. Everybody is like, thank you, very informative and knowledgeable session.
Thank you. Thanks to Bhagavati ma'am, because I had physically visited that university and I interacted, and that was so good because we can teach in a better way. But anyway, we could try as much as possible. Thank you.
Excuse me, sir.
Our pleasure, sir.
I'm Ganesan from Alapur University. The session was excellent, sir.
Thank you.
And the simplest way you have used it. Sir, this is since you are economics professor, I have one question. You said the average salary. You mentioned average salary may be 70,000, 650, whatever it may be. But salary wise, if you take the average salary of Indian people, you are calculating the 100% salary of the people. In which, for example, if you take 10 persons, maybe Ambani will be having 1 lakh crore, the other person will be having 4 lakh crore.
Obviously.
So 10% will be having 95% of the income, and remaining 99 point something people will have only.
I got your question, Ganesan.
Then how this average?
I got your question. I got your question. That is why statisticians helped us to measure kurtosis and skewness. If you find the skewness, if it is more skewed, you can ignore that sample. You can easily go for histogram and you can find out where there are outliers are there. Everybody must be clustered around one particular mean. If somebody is on top, keep away.
Yes.
Understand? Keep away. There is a possibility of identifying the outliers and keep them away from the sample, because that one person will disturb everybody.
Yes, sir.
Even in my class, most of the people will be scoring only around 70 and only one person always score 98. We will always keep him away because we will discuss only among ourselves. We will compare only our marks. So we should have a normal distribution. You can test the normal distribution. You can test the skewness and kurtosis. Based on that, you can check the outliers, and outliers can be kept away. Okay, fine.
Yes, yes, sir.
Thank you.
Thank you.
ma'am.
Thank you.
Shall we wind up, ma'am?
Yes, sir. Yes, sir. Yes,
Thank
sir.
you. Yeah,
Yeah.
fine, fine,
See you
fine.
tomorrow.
Yeah,
Thank
thank
you,
you.
sir.
See you tomorrow. Fine.
Participants are requested to fill out the feedback form, which is sent on the chat box. The new link has been pasted, so kindly use that link. It's also pasted in the chat box of the YouTube channel as well. I'm also dropping the link for tomorrow. We hope to see you tomorrow again to learn and grow with us. I hope today's session was very informative for you. In case you have any doubts or questions, please keep it with you. Like tomorrow when we discuss, we'll definitely ask our resource person. Thank you so much for joining. Have a great day ahead.
Thank you.